Hello students, welcome to the class. So, how are you? I hope your preparations are going well for your JEE exams. So, quickly join the class. We will begin our class in few minutes. So, today the topic will be solutions, right? We have covered already some chapters of the physical chemistry and one chapter for the inorganic chemistry. So, if you have a doubt, you can ask it here and join the class as soon as possible. We will begin our class in few minutes. So, please join the class. So, any doubt from the previous class? So, we have covered already some chapters of physical chemistry, including thermodynamics, atomic structure, and some basic concepts of chemistry. We have also went through one of the inorganic chapters, which is chemical bonding and molecular structure. Today, we will do a very easy chapter, but a scoring one, which is solutions. It is totally based upon formulas. You don't have to worry much about it. So, this is something which can help you to score easily in the exams. I will suggest all of you to please pay attention to this chapter, and doing PYQs of this chapter is enough. Okay, so if you are covering your NCRT and you are doing the PYQs, that would be enough for your solutions chapter. So let us begin our class. This is disclaimer. Okay, so we will practice question. We will also practice question for it. Before that, let us see some theory part. So what are we going to cover today? Let's see. First of all, we will look upon concentration of solutions. So we have seen about this in the first class also, where we have covered the chapter some basic concepts of chemistry, but we will go through it again as it is important for this chapter. So we will cover some part of concentration, which is molarity and molality, and I have put some formulas also. Apart from previous class, we have some formulas also which relate your molarity and molality, so that would be important for us. Then moving on to the next, which is our solubility. So we will learn what is solubility, because we are dealing with solutions. So we must know what is solubility, and then we will look upon vapor pressure. So this term vapor pressure is something which is related to the pressure exerted by the vapors formed from the solution. Okay. Then after, we will look upon factors affecting vapor pressure, and then we will move on to the first important topic of this chapter, which is Raoult's law. So there is a build up behind this chapter, but still it is important. And after this Raoult's law, we will look upon ideal solution which is related to your Raoult's law and your non-ideal solutions. Then after, we will move on to the types of non-ideal solution, which includes the solution showing positive deviation and the solutions showing negative deviations. Lastly, we will summarize it all with a short summary, starting with the concentration of solution. So what is molality? So this thing is already taught in the class, so I would first expect you all to give the answer. So what will be the formula of molality? So please write it down in the comment section, then only we will move further. Okay, so we have talked about this molality in the previous class also, but there is a small extension to this which is important for solving problems in exam. But before that, I want to ensure that you are attending all the classes of the previous sessions carefully. So what is the formula for molality? All of you, please write it down in the comment section. So it's a very important topic related to concentration of solution. We have 4 types of concentration: molality, molarity, normality and mole fraction. And we have 2 more subsidiary concentration terms which are ppm, parts per million, and percentage, okay, weight by weight percentage. So please comment it quickly. What is the formula for molality? Let me give you the definition first of all. So it is denoted by small m, and it is defined as the number of moles of solute dissolved in 1000 gram of the solvent. Now here are some important points related to it. First thing is that you are interested in the amount of solvent, and you should take the amount of solvent in 1000 gram or in terms of kg. Now from this we can define the formula: molality is equals to number of moles of solute dissolved in per kg of that solvent. Now how do you calculate the number of moles of solute? It's very easy. If you are given with the mass of your solute, then you can simply divide it by the molar mass to get your number of moles. Okay, yes, very good, Dhruv. So the molality formula will be moles of solute divided by mass of solvent in kg. Now moving on to the next one, molarity, which is represented by capital M. So how do we write the formula for molarity? Anyone? What is the formula for molarity? So it is not said that why it is in kg. There is a not definite reason behind it. It is just a way to define the concentration. Okay, there is no reason behind it. So what will be the formula of molarity? So we know that it is represented by capital M. I would request all of you to please be engaged in this class so that I can also feel good while giving you the lectures. Okay. Now it is defined as the number of moles of solute which is present in per liter of the solution. So here we are interested in solution. There it was for per kg of solvent. Here it is for per liter of solution. Now if that is the situation, what will be the formula of molarity? It will be number of moles of solute divided by volume of solution in liter. Yes, Dhruv, very good. It will be volume of solution in liter. Now a very important relation between molality and molarity. What is that relation? So if you are given with the density of the solution and the molar mass of the solute, then you can calculate the molarity by using molality. What is the formula? Write it down. It's very important for you. It is m into d divided by 1 plus m into m2 by 1000. So if you are not using that formula, it will be very difficult to solve such questions where you are given the molar mass of solute, the molality and the density, and you are asked to calculate the molarity. So this is a very important formula to calculate the molarity directly. As I said earlier, m2 is the molar mass of solute, d is the density of the solution, and small m is the molality of the solution. Now we have another important relation between molarity and density. What is that relation? So molarity is equals to 10 times the density multiplied by the percentage weight of the solute divided by the molecular weight of the solute. So anyone, can you tell me what is percentage weight of solute? How do we calculate it? So D is the density of the solution. Okay. So can anyone tell me what is percentage weight of the solute? How do we calculate it? I would suggest all of you to please give me answers in the comment section. Come on, give your answers in the comment section. What is percentage weight of the solute? So it is simply the percentage, okay, which is used in your daily calculation. So that percentage is also used here also for the percentage weight of solute. You have solute and solvent in your total solution and you have to calculate the percentage weight of solute. Yes, it will be the mass of solute divided by the mass of solution into 100. Okay, remember both masses should be in the same unit. Got it? Both the masses should be in the same unit. Then and then only it will be correct. Suppose you are taking the mass of solute in gram, you should also take the mass of solution in gram. If you are taking the mass of solvent in gram, then you should also take the mass of solvent in gram. Okay, so this is important to remember. If you are taking it in kg, both should be in kg. If you are taking it in milligram, both should be in milligram. Or else it will give you a wrong answer. Got it? Is it clear to all of you? So this formula is very, very important. Molarity is equals to 10 times density times the percentage weight of solute divided by the molecular weight of solute. Okay, so this was all about molarity, and now we have two another important relations. First is the relation between molarity and the molality, and the second one is the relation between the molarity and the percentage weight. Next we have mole fraction. So what is the formula for mole fraction? So it's a easy one. You know that it is the ratio of the number of moles of one component for which you are calculating, either for solute or for solvent, divided by the total number of moles, which includes your solute and solvent both. So this will give you your mole fraction and it is represented by chi. Okay. So what will be the formula if this is the definition? It is quite clear now if you know the formula, if you know the definition. So what will be the formula to calculate the mole fraction? Suppose I am telling it to calculate the mole fraction of the solute. Then what will the formula of that for that? So I hope many of you are attending the class. So please comment it down if you know it, because this will help you to revise these formulas. In exams, there may be a chance that you may get confused in between these formulas. So what will the formula of mole fraction chi for the solute if we are having only two types of components, solute and solvent? Yes, very good. It will be number of moles of solute divided by total number of moles, which includes the moles of solute and the moles of solvent. Okay. Now, next, if you write it here, it will be number of moles of solute by total moles of the solution. Very good, Pratham. Okay. Now, next, if I ask you that is there any rule for it? Can we calculate the number of, the mole fraction of the solvent if we know the mole fraction of the solute? Is there a direct formula for it? Can we calculate it directly without knowing the number of moles of solvent? It's a very easy one. Again, I am repeating my question. You have to calculate the mole fraction of the solvent and you know the mole fraction of the solute, given that your solution contains only two types of component, one solute and one solvent. Then what will be the formula to calculate it? Can we calculate it directly? It's a very easy one. Anyone who is willing to give the answer? So I will repeat my question once again. You have to calculate the number of moles, sorry, you have to calculate the mole fraction of solvent, and you are given the mole fraction of solute, and your whole solution is composed only two types. One is solute and one is solvent. Yes, very good. So that formula would be 1 minus number of moles of, sorry, 1 minus mole fraction of solute. Okay, very good. So this will be your way. Now remember students, you won't make a mistake in this. If there are only two components, then and then only you can apply this formula. Got it? So if I calculate it simply without using the shortcut, it will be number of moles of solvent divided by the total number of moles of solution. And this is the formula to do so. If there are multiple components, suppose there are three components A, B and C, then in that case, if you want to calculate the mole fraction of C and you know the mole fraction of A and B both, then and then only you can calculate the mole fraction of C. Got it? So in case of multi-component, means more than one component is present there, you can't have only one to calculate it. You have to have multiple mole fractions to calculate it. Suppose there are three components, so that would be chi A plus chi B plus chi C is equals to 1. Is it clear to all of you? Okay. Now this mole fraction is the one which will be used mainly in your calculations, because in solution part you will see the application of mole fraction in a greater way. Now moving on to important relation. So we have already seen two important relations. One was between molarity and molality, and the second one was between molarity and your density, sorry, and your percentage weight. Here we have a relation between molarity and mole fraction. I will suggest you all to include these formulas that I have told you right now in your content. Got it? If you don't know it, because questions can be directly solved from it, and I will show you some PYQs which are solved using those formulas. Next we have the relationship between molarity and mole fraction. So suppose you want to calculate the mole fraction of the component 2, component number 2, and your solution is composed of two type of components, 1 and 2. Then in that case, the mole fraction of 2 will be calculated as m into m1 divided by m into m1 minus m2 plus d. Here, what are the symbols therefore? So capital M1 is for the molar mass of solvent, that is your component number 1. M2 is the molar mass of solute, which is your component number 2, and your D is the density of the whole solution, and lastly your chi 2 is the mole fraction of solute. Got it? And your capital M here is representing the molarity of your solution. Any confusion in this formula? Again I am telling it, it's very very important. This can be directly used in your exams to calculate the required quantity. Is it clear to all of you? Any confusion in this formula related to any term? Okay, again I am telling it. Suppose you want to calculate the mole fraction of your solute, which is chi 2, and what you know is the molarity of the solution, molar mass of the solvent, molar mass of the solute, and density of the solution. Then you can use this formula, which is capital M, which is molarity, multiplied by capital M1, which is molar mass of solvent, divided by capital M into M1 minus M2 plus D. Okay, so this is a direct formula. We will not look upon the derivation, since we are trying to cover all the parts. Okay, and derivation is not at all important. Okay, so is this formula clear to you? When it can be used? It is used to calculate the mole fraction. Any doubt? Now is it clear to you? Yes, there is a delay. No worries about that. So there is something, there is a system restraint to it. So I will take care of it. So is it clear to all of you? Is this formula clear to all of you? Can we move further? Dhruv, Partham, VK. So can we move further now? Any doubt in this? Partham, is it clear to you? So you were asking about the it that you have to explain it one more time. Now is it clear to you? So I want to make sure that those who are attending it, at least they should get it clearly. Okay. I hope Partham got the point. Now moving on further. Next is your percentage by weight or mass percent. So as the name suggests it clearly, so it is the amount of solute which is present in 100 gram of the solution. Okay, remember this definition is very important. It will help you to solve your question. By knowing the percentage weight, you know that how much amount of solute is present in 100 gram of the solution. Now this is your formula. Suppose you are getting 10 marks out of 20. So what will be your percentage? Your percentage will be 50. Means it is a way to represent your marks in terms of 100 marks. Okay, got it? So percentage is something which helps you to measure the things in terms of 100. Got it? So here if you are getting suppose 2% weight by weight for the solute, it means that your 100 gram of the solution contains 2 gram solute and rest of them is the solvent. Okay, so this is the way to look upon the percentage by weight or mass percent, and it's very important to understand its thinking or understand the rationale behind it. Okay, got it? Now this is something which is related to 100 gram, but suppose we are trying to relate it with the volume rather than your weight. Now we are talking it in terms of volume. Yes, you are saying it right. It is like a ratio and we are trying to keep it in terms of 100. Now suppose I am telling that this thing is related to volume. Now it means that it is the amount of solute which is present in 100 milliliter of the solution. Okay, so we can say it in this way, that volume of solute in milliliter divided by volume of solution in milliliter multiplied by 100. Remember students, this can also be written in terms of liter. You don't have to worry about it. If suppose I said that your given percentage is 2 percentage weight percentage by volume. What did I say? Your given concentration is 2 percentage by volume. Then what is the meaning of this? You can think of it in different ways. You can say that 2 milliliter of solute is present in 100 milliliter of solution. That is true. But you can also say that 2 liter of your solute is present in 100 milliliter of solution. Okay. So whatever be the units you are taking here, no matter which unit you are taking, but you can tell it in terms of every unit you want. You got my point? So it is not dependent upon the unit you are taking it here. The thing we should be cared of is that your both units should be same, but your outcome which you are getting, that can be rationalized in every unit. Got it? So suppose you got the calculation and you got your percentage by volume as 2%. Now from here you can say multiple things. What are the things you can say? You can say that 2 liter of your solute is present in 100 milliliter of in 100 liter of solution, or you can also say 2 milliliter of your solute is present in 100 milliliter of a solution. Why I am saying this? Because unit will get cancelled out. If you keep both of them in liter, then also you will get the same percentage by volume. If you keep both of them in suppose microliter, you will get the same percentage by volume. I hope you are getting my point here. Because the ratio is common, it will be get cancelled out. Now we have our last thing. Now this thing, if you just look upon a medicine, suppose you take a medicine, you see it in the back, in the description part where the ingredients or your composition is mentioned, there we use this mass by volume percent. Got it? So it is basically the mass of solute dissolved in 100 ml of solution. So in most of the cases you will see that gram per ml is used. Okay, so the mass of solute is mentioned in terms of gram and total volume is given in terms of milliliter. Now this will be defined in your question. You don't have to worry about it. Suppose your question is asking to calculate the mass by volume percentage, then it will mention that your mass should be in gram and volume should be in milliliter. Got it? So you don't have to worry about it, that which unit you are going to take. But in percentage by volume or in percentage by weight, the numerator and denominator both should have the same unit. I hope you are getting my point. Now, if this part is clear, where I said that we were talking about 100 parts, here we will talk about the parts per million, means in the million part. Got it? So rather than multiplying by 100, we will multiply it by 10 to the power 6. So here we will say that if I am suppose I am calculating it for a solute whose mass is given in gram, then we will calculate it in this way, that your mass of solute will be present in 10 to the power 6 liter of your solution. Got it? So this is your way. This is your formula for ppm, which is parts per million. So the formula is almost same, mass of solute in grams, volume of the solution in milliliter, but you are multiplying it with 10 to the power 6, because here you are interested in the parts per million, and million is represented by 10 to the power 6. So this is the basic difference. In the case of weight by volume percentage, you were multiplying it with 100 because you were interested it in the hundreds part, but here you are interested in the millions part. Now why do we use it? Why we are talking about such large amount of solvent? The reason is that your concentration is sometimes very small in some cases. Suppose you talk about water. In water, bodies like your sea or river, if you talk about concentrations of your salt or concentrations of some hazardous substance, then there you talk about a very small concentration of solute in a large amount of water. So in that case, you have to use such ppm where you have to consider a large amount of water body. Got it? So that is the reason we use the parts per million. Now, keeping apart that application, you should remember that your parts per million is calculated by this formula, which is mass of solute in gram, volume of solution in milliliter, multiplied by 10 to the power 6. I hope this is clear to you. Now, moving on to something which is called normality. This normality will be used in your equilibrium, ionic equilibrium, when we will see the titration, or we will talk about acid base neutralization. There we will see this normality. We will use this formula also in the upcoming questions. So it is the number of gram equivalents present in per liter of the solution. Sorry. And how do you calculate it? So normality is given by number of gram equivalents of solute by volume of solution in liter, where the gram equivalent is calculated by the weight of the solute divided by the equivalent weight of solute. Now you ask me, how do you calculate the equivalent weight of solute? It's very easy. So it is molar mass of solute divided by the N factor. Okay, so this was something which was very difficult to understand for some of you, I hope. So is it clear to all of you? I will give you some time to think about it. All who are attending the class, so please think about it. Are you getting my thing? Especially regarding this ppm and normality. Any doubt till this point? Dhruv, Partham, VK, or anyone else who is attending the class? So are you getting the point here? Is normality clear to you? If it is clear to you, can you write the formula for equivalent weight of solute? What will be the equivalent weight for solute? What will be the formula for that? So, Partham, are you there? Are you attending the class? Yes. So can you tell me what will the formula for equivalent weight? So we have the formula for normality, which is number of gram equivalent of solute by volume of solution. Then we have formula for this gram equivalent, which is weight of solute by equivalent weight of solute. Now I am asking you that what is the formula for equivalent weight of solute? So can you write it down? Yes, very good. So that would be the molar mass by n factor. Okay. So VK, are you there? Are you attending the class? So please, can you all send me a hi if you are attending my class, so that I can ask all of you whether you are getting my point or not. Okay. So very good. So that would be molar mass by n factor. See, these are some important formulas for your exams. Now, I am giving you a question here. Think about it. I will move forward. You can just answer it here. So I am giving you three species. First of all, suppose the first one is Br minus, which is bromide ion. Second one is NaOH, and third one is H2SO4. Again, I am repeating it. First one is bromide ion, second one is NaOH, and third one is H2SO4. So, can you give me n factor for all of these three? You get my point? You have to tell me the n factor for H2SO4, NaOH, and Br minus, which is bromide ion. Okay. Now I am leaving this on to you. You can just comment it down. So this was all about the concentration term, and now we will move on to solubility. What is solubility? It is the maximum amount of solute which can be dissolved in a given solvent. Okay, take for instance, you are trying to dissolve sugar in water. If you keep on dissolving it, after some time you will see that further dissolution is not possible and it will settle down in the bottom. Okay, so at that point you say that your given thing is being saturated. Okay, so I am getting some answers here. So for bromide ion, which is Br minus, it will be 1. For every ion, its n factor is simply equals to its charge. Got it? And this will be seen in this Br minus thing will be seen in your redox reactions. Okay. Then, got it? Then if I talk about NaOH, so NaOH is mainly used in your acid base reaction. You know it very well. So in acid base reactions, your OH minus count is simply your n factor. So for sodium hydroxide, it will be 1. And for H2SO4, which is a diprotic acid, it can donate 2 H plus. So in that case, your n factor will be 2. Is it clear to all of you? So basically it depends upon the reaction. Sorry for not telling you the context, but I hope you are getting my point, right? Is it clear now? So for ions, it is always the charge. In case of acid base reactions, it depends upon the number of H plus and OH minus it is donating. And here for NaOH it will be 1 and for H2SO4 it will be 2. So is it clear to all of you? Okay. So if it is clear, now we can move on with the solubility. So solubility of a gas, it depends upon temperature and pressure, and that is very obvious, because if we talk about gas, so if you want to dissolve gas in liquid, so basically you are trying to move your gaseous molecule into the liquid phase. So you know that the energy of the liquid phase is less than that of your gaseous phase. Got it? Is it clear to you? Yeah, for NaOH it will be 1, because NaOH will give you 1 OH minus. Now NaOH will have a n factor of 1 because it can give you 1 OH minus. Now, as I said, that the solubility of a gas depends upon temperature and pressure, because your gaseous molecule has to go into the liquid phase to be soluble. If this is true, that means your gaseous molecule should be lowered in energy. Now, to lower its energy, there are several factors which includes your temperature and pressure, because temperature is a kind of energy. If you increase the temperature, the gas molecule will get more energy, and in that case it will not move into the liquid phase because of high energy. Got it? And similarly for pressure. So if you want to dissolve your gaseous molecule into liquid, you have to apply high pressure. Your simple example is carbonated drink, in which you have high pressure carbon dioxide infused into the soda drink, right? So that is a very quick example of how pressure can change the solubility, and as soon as you open the lid, you can see that your gaseous molecule comes out of the liquid phase. Got it? Now, there is a quantitative relationship between pressure and solubility of a gas, which is given by Henry's law. So, can you write it down? What is the mathematical formulation of Henry's law? So, it is in terms of the mole fraction of your gas which is to be dissolved and the partial pressure of the gas which is to be dissolved. So, what is the relation? What is the mathematical formulation of Henry's law? Can you just write it in the comment section? Anyone? What will be the mathematical formulation of Henry's law? So, it is used for a solution where the solute is gas and the solvent is your liquid. Very good. It will be C is equals to KHXP. Any more answers? Is there any other formulation of Henry's law? There is a small mistake in your answer, so just think about it once again. So, what is the mathematical formulation for Henry's law? I would expect more answers from you. So, anyone else? Partham, anyone who is willing to give the answer? The mathematical formulation for Henry's law? Okay, so let me give it for you. It is P is equals to KH chi. Okay, P is equals to KH chi, where P is the pressure of the gas above the liquid, then chi is your mole fraction of the gas, and KH is the Henry constant. And this Henry constant that you are talking about is very important for you. Yes, this is your correct form. Very good, VK. So it will be P is equals to KHX, where KH is the Henry constant. Now, can you tell me whether this Henry constant is there for solvent or is it for solute? For which it is defined? KH is for the solvent or is it for solute? Can anyone tell me? For which species it is defined? Is it for solute or is it for solvent? Your KH value? Can you tell me for which species it is defined? Is it defined for solvent or is it defined for solute? So it is very important to understand the aspects of a formula or it may confuse you. Again, I am repeating my question. For which thing it is defined? Whether the KH is for the solute or it is for or is it for a solvent? Yes, very good. So I am getting answer here. Yes, your KH value is defined for solvent. So I will request all of you to give the answer. Those who all are attending the class, KH is defined for different solvents. Right. Now this formula is important. Please note it down. P is equals to KHX and it is for the gas dissolved in a liquid. Moving on to vapor pressure. So now we are moving on to liquid solution. So whenever you dissolve a liquid into a liquid, there is of course some sort of evaporation, and that evaporation will lead to some gaseous molecule, and the pressure exerted by those gaseous molecule is known as the vapor pressure. What are the factors that affect the vapor pressure? First is the purity of the liquid. Okay, so pure liquids has a vapor pressure higher than its solution. Second is the nature of the liquid. So if a molecule is, or if the liquid is more volatile, or it has a weak intermolecular force, then it will have a greater vapor pressure as its molecule are more intended to go in the vapor phase. Moving on further, then we have temperature. So higher temperature means molecules can easily go into the gaseous phase, resulting in higher vapor pressure because the temperature gives them enough kinetic energy. Then next factor is effect of adding solute. So if you are adding a non-volatile solute, then it will result in a lower vapor pressure. And the reason is that why it is happening, because only those molecules goes into the gaseous phase which are on the upper surface. Got it? So whenever you take a liquid, only those molecules go into the vapor phase which are in the upper surface. Suppose you are putting a non-volatile solute into a solvent, then what will happen? The upper surface will be occupied by both solute and the solvent, and those solute particles which are non-volatile. As a result of this, the solvent particle will be less exposed to the environment and they will be going less into the vapor phase. So as a result of this, your vapor phase, your vapor pressure decreases. Now we have a relation for it. Again, I am repeating my part. So this is very important to understand, and it is true for those kind of situations where your solvent is volatile in nature and you are putting a non-volatile solute. Now, are you clear about volatile and non-volatile? So volatile is something which can easily go into the vapor phase, and non-volatile is something which expects or which tries to remain in the gaseous, in the solid phase or in the liquid phase. For example, if you take water and if you take alcohol, so alcohol is highly volatile. It goes quickly into the vapor phase, whereas your water, it is non-volatile in nature. Now what did I say? When you dissolve a non-volatile liquid into a volatile liquid, it decreases its vapor pressure. So to quantify that, how much decrease is seen, we have this relative lowering of vapor pressure, which is given by your Raoult's law further. So if I try to define the relative lowering of vapor pressure, what it will be? It will be P naught minus Ps by P naught. Why I am telling it as relative lowering? So this P naught minus Ps is the lowering, and when we divide it by the P naught, we get the relative lowering. You got it? With relation with relative to the P naught. Any doubt in this part? So this is the important part, or this is the important part regarding the factor affecting vapor pressure. Is there a doubt in this part? So you can just post your doubt right now. I am waiting for some time. So anyone has a doubt in this part? Is it clear to all of you? Are you getting this term? What is relative lowering? So this is very important. It will be used in your colligative properties. So first of all, I defined that you are taking a volatile solvent and a non-volatile solute. So volatile means which can easily go into the vapor phase. So when you dissolve a non-volatile solute in the volatile solvent, it results in the lowering of the vapor pressure. So that lowering can be written as P naught minus Ps. Okay. Then it can be called as relative lowering when you relate it to the P naught. So this is an important mathematical term and it will be used further. So is it clear to you, Partham, VK, Sijay? Any doubt in this part? Are you getting this whole point? So even if you miss this factor affecting vapor pressure, the previous part, this part is the most important one, I would say. Oh, okay. I hope you are getting the point. I'm moving forward now. So moving on to the next thing, which is known as Rawls' law. So we studied this Henry's law, and now we will move on to the Rawls' law. What is Rawls' law? It says that the partial pressure of each component of the solution is directly proportional to the mole fraction of that component present in that solution. Now, let me write it mathematically, and that is your most important part, which says that what is Pa here? So, Pa is the partial pressure of A. Suppose you dissolve two things, A and B, right? Now, in that solution, both of them will have some amount of vapor pressure because both of them will go from solution phase to the vapor phase and it will exert pressure. As a result of this, there will be some pressure of A and some pressure of B. So that only thing that is termed as partial pressure of A and partial pressure of B. Got it? Now we can directly calculate the partial pressure of both of them, of the A and B, and it can be calculated as Pa is equals to chi A P naught A, where P naught A is the pressure of the pure liquid A. Suppose you take A in the pure form and you take a mixture of A and B, then the partial pressure of A in the solution will be Pa and the partial pressure of the pure liquid will be P naught A, and chi A will be the mole fraction. Okay, it will be the mole fraction of A in the liquid phase. Which phase? Liquid phase. Remember, this is very important to understand, because just after this you will see a similar kind of formula but with a small change. What did I say? Pa is the partial pressure of A in its pure form, in its solution phase. P naught A is the pressure of A in the pure form, and chi A is the mole fraction of A in the liquid phase that you are taking. So this is important to understand. The aspect of the formula is the most important one. If you are not getting this thing, then you will find it difficult to solve problems. Got it? So from my experience, how much I have gained, I have seen that most of the students find it difficult to solve the problem because they know the formula, but they don't know to apply it because the aspects or the terminology of the formulas are not clear to them. Okay, so this is related to B and similarly to A. Now there is this next formula which is very important. What does it say? It says that the partial pressure of A can be also written as chi A into P total, where P total is the total pressure, means Pa plus Pb. And what is chi A here? So this chi A is different from the previous one. This chi A is the mole fraction of A in the gaseous phase. This chi A is the mole fraction of A in the gaseous phase, whereas in the previous formula, this chi A was the mole fraction of A in the solution phase. You can use a different notation for it also. In NCERT, you will say see that rather than writing chi A for the gas phase, we use the term Ya. Is it clear to all of you? Any doubt in this? Two formulas. So I hope you are getting the two formulas. Now we can just write it here. In case of non-volatile solutes, the P solution is equals to chi solvent into P naught solvent. So the formula that you are seeing here above, it is there for the components which are volatile in nature. Got it? And for non-volatile, it is given in this way. Is it clear to all of you? Any doubt in this part? So if anyone has a doubt, you can just comment it here. So from this, I will move faster now. Okay, because after this part, there is just the application of what we have studied till now. So I will move faster from here. So this should be clear to you. If you want, you can just write these formulas. I will use them consecutively in the next slides. So anyone who has a doubt in this? Okay, so I am assuming that all of you are getting my point. If you have a doubt, you can still ask it, but now I will, from this part I will move fast because this is now just the application of what we have seen. Now before moving on to the application, let us look on to some of the limitations of Rolle's law. Just listen it very carefully. It is only applicable for dilute solutions, means the amount of solute should be less, or else it will not be applicable. Second thing, it is applicable to only those solution which contains non-volatile or non-electrolyte solutes. What did I say? That your solution should contain non-volatile and non-electrolyte solute. Means the solute should be non-volatile as well as non-electrolyte. Third point, it is not applicable to those solutes where it is dissociating or associating. It is the same thing. Non-electrolyte means the same thing. Okay. So if you consider some electrolyte solute, suppose if you take NaCl, it is an electrolytic solute. It can dissociate or associate. So in that case, your Rolle's law will not be applicable. Now, moving on further to the ideal solution. So, what are ideal solutions? All those solutions that obeys your Rolle's law in all range of concentration and temperature. Means you can take any concentration, you can take any temperature, but that solution will obey the Rolle's law. That is, Pa is equals to chi A Pb. Similarly, P naught B and Pb is equals to chi naught Pb. Okay, so this should be applicable to all of them. Now, an important thing here. So for ideal solution, the enthalpy of mixing is 0, means there is no heat released or no heat absorbed if you take and dissolve the two components of the ideal solution. How? Suppose you said that this solution is ideal. Now if your solution is ideal, then your enthalpy of mixing should be 0 and your volume should also not change. Suppose you take 2 liter of the solute and 2 liters of the solvent, then the resulting should be of 4 liter. There should be no change in the volume after mixing. Got it? As I said it earlier, delta H mix is the enthalpy of mixing, a change in enthalpy, and delta V mix is the volume of mixing. Got it? Next, in this case, all the interactions are of same strength. So solute-solute interaction is equals to solvent-solvent interaction is equals to solute-solvent interaction. Means the strength of interaction, the force with which your molecule are attracting each other, that should be same between the solute and solute, between the solvent and solvent, and between the solute and solvent. Then and then only your given solution will behave like an ideal one, or else it will not. Examples. So there are no perfect ideal solutions, but still we have some solutions which can show a closeness to this ideal condition, which are N-hexane and N-heptane. So this is the first example. Second is benzene and toluene. So each of these two solutions fall in the category of ideal solutions. Is it clear to all of you? Any doubt in this part? Anyone who has a doubt in this? So we have to do questions also. So please comment it quickly whether it is clear to you or not. Remember this characteristics, this given characteristics of ideal solution is very important. Okay, questions, theoretical questions can be directly asked from this. Anyone who has a doubt in this part? Okay, so I am assuming it is clear to all of you. Now, next, graphical representation of ideal solution. So as I said, practically no solution is ideal, but still you can see some sort of means closeness towards this ideal solution. As I said you, so listen very carefully to this graph. You know two equations. If I have A and B, the first equation says that PA is equals to chi A P naught A. Got it? And PB is equals to chi naught P naught B. Therefore, the total pressure will be the partial pressure of A plus the partial pressure of B. That means P naught A chi A plus P naught B chi B. Is it clear? Next, as you keep on increasing the amount of A, you look upon this mole fraction. Okay, so here the mole fraction of A is 1 and here it is decreasing to 0. Means initially only A is present in the given beaker and then you are slowly adding B to it. What will happen? You will add it and finally you will see that your chi A is 0 and your chi B is 1. Means now you are only having B. During this, what will be the change in the partial pressure of A? So as you are decreasing A, the partial pressure of A is decreasing. You can see here this line, which is P naught A chi A, or the partial pressure of PA, it is decreasing. Similarly, if you are increasing the B on going from left to right, therefore your partial pressure of B will increase, so your PB will increase. So P naught B chi B is increasing. So this is the meaning of these two dotted lines. Got it? So you are decreasing A, so P naught A chi A is decreasing, and you are increasing B, so P naught B chi B is increasing. Got it? What about the total pressure? We assume that your B is more volatile than A. Since B is more volatile than A, so as you will increase B, the total pressure will increase because the partial pressure of B is higher always. So therefore you can see that as you are introducing more and more B into the solution, the total pressure is increasing. And this is the solid line representing your total pressure. Is this graph clear to you? Anyone who has a doubt in this graph can ask it now. So there are multiple times questions are asked from this graph. Are you getting the reason behind these three lines that you are seeing, the two dotted lines and a solid line? So VK, Dhruv, Partham, Shijan, is it clear to you? Are the three graphs clear to you? How we are moving from left to right and what are the things that are changing during this whole time? Any doubt in this graph? Okay. So now we shall move forward. So if you have a doubt, you can ask it now because this graph will be now moved on to positive and negative deviation. Okay, so I am moving forward. Next is non-ideal solution. It's very simple. The solution which show deviation from Raoult's law are non-ideal solution, and for those kind of solution, the delta H mix and the delta V mix is not equals to 0. Means there is a change in volume and there is a change of enthalpy. Means some amount of heat is released during the mixing of those two components. First of all, what are positive deviation? So if the partial pressure from each component is higher than the expected one, then in that case we see a positive deviation. And for positive deviation, two very important points, that your enthalpy of mixing is greater than 0 and the enthalpy of and the volume mixing is greater than 0. Got it? Just write it down, it's very important. And it is usually observed for those two liquids when one is polar and the other one is non-polar in nature. For example, cyclohexane and ethanol. So cyclohexane is non-polar, whereas ethanol is containing an alcoholic group, so it is polar. Similarly, if you compare ethanol and water, water is more polar and ethanol is less polar. So they will give you a positive deviation. Can we see a graph of it? Yes. So this is your graph. You can see that if this is your PA, this is the expected one, the dotted one, but you are getting a higher pressure. Similarly, this is for B, but you are getting a higher pressure. As a result of this, the total pressure is also increased by some amount. So we can say that your pressure of A is greater than P naught A chi A, which is the predicted one by Rolle's law. Similarly, the pressure of B is greater than P naught B chi B, which is the predicted of Rolle's law. Therefore, the total pressure is also greater than the predicted one. So the predicted one is P naught A chi A plus P naught B chi B, but your actual pressure is greater than that due to the positive deviation. Why it is happening? What is the reason behind it? So when you are dissolving a polar and a non-polar solution, they do not interact well, and as a result of this worst interaction, they are leaving the liquid solution easily and forming vapor. So the vapor pressure is increasing. Got it? But when you move on to the negative deviation, here the interaction is greater, means it increases. Now the stronger interaction is seen, and as a result of this, there is a negative deviation, and your delta H mix is less than 0 and delta V mix is less than 0. So this is thus the opposite of positive deviation. And you can take the example of chloroform and acetone. Can we take examples of it? Yes. So first one is chloroform and acetone, and second one is this. Now moving on to the graphical representation. Opposite to that of seen in the positive deviation, here the total pressure is lesser. You can see a dip in this. Similarly, the partial pressure of A is less and the partial pressure of B is also less than the predicted one. So we can write it mathematically that PA will be, means the observed pressure is less than the predicted pressure, which is P naught A chi A. Similarly, the observed pressure PB is less than the P naught B chi B, and hence your total pressure is also less than the predicted total pressure. Is it clear to all of you? Any doubt in this part? So this was all about theory. Now I am giving you some time, 2 to 3 minutes. If you have a doubt in this whole theory part, you can just post it here. I will try to solve it. Or still, if you are facing difficulty, you can just come and ask it in the doubt clearing session of our SATHEE, which starts from 10 AM and ends at 6 PM. Or you can post your question at our SATHEE forum. Now I will give you some time so that you can ask questions here also, and I will move on to the questions part. Okay, so we will do some PYQs of this chapter related to the formulas that we have studied now. Most of the questions will be from our, say, this concentration part. So is it clear to all of you? Anyone has a doubt? So I am now ending this theory part. So here is your first question. If 1 molar solution of sodium chloride has a density of 1.21 gram per ml, the molarity is to be calculated. Now this is directly from the formula we have discussed today, and it is one of the PYQs. Got it? What is given? Your molality is given. It is given as 1 molal, means 1 m is the molality. Then what else is given? The density is given, which is 1.21 gram per ml. The third thing which is given is your molar mass of solute. How? Why I am saying it? Because it is given that your solute is sodium chloride. So the molar mass is 58.5. So I will give you some time to solve this question. You have to calculate the molarity. I said it earlier to please write down the formula. You can use that formula directly to calculate your answer. So your time starts now. So I will wait till 5:06, sorry 5:07 to calculate this. So please calculate it quickly. You can use calculator for the time being. Okay, since we are in our crash course, you can use calculator for the time being. but please solve it quickly. And write down your answer in the comment section. So we have seen a formula. We are given with the molality, we are given with the density, and we know the molar mass of the solute. As the solute is sodium chloride, you have to directly calculate the molarity. I have given you a direct formula to calculate this, so please use that formula. If you have not noted it down, then I would suggest you to please follow me whenever I am telling you the formulas, because it's a direct one. You don't have to use your brain, you just have to put the values and take out the answer. Anyone who is willing to give the answer? Dhruv, VK, Partham. So please post your answer in the comment section. Anyone? What will be the answer for this question? There is a direct formula for it. Okay, so I'm getting answer here. Answer is B. Let's see. I want more answers from you. Anyone else who is willing to give the answer? So what will be the answer for this? Dhruv, Partham, what will be the answer for this question? Okay, so let us see the answer. I hope I'm seeing that you are not getting your answer. No worries. Let me solve it for you. So the correct answer will be B, 1.143. So your answer is correct, VK. Let's see how we'll solve it. So we know that the molar mass of NaCl is 58.5. Now this is your direct formula that you can use, which is m into d divided by 1 plus m into m2 by 1000. So the molality is given, it is 1, since it is given as 1 molal. Then we know the density, it is 1.21 gram per ml. Further, we have m2 as 58.5 because here the solute is sodium chloride and the molar mass of solute is 58.5. Just put it here, you will get it as 1.143 m. Now, who are not able to solve it, did you get the answer? Now, if you have any confusion, you can just ask it, or if you are getting it, you can send a thumbs up. So now, is it clear to all of you? Those who are facing difficulty to solve it, just please send the thumbs up if you got the answer, or if you are now understanding the solution. Is it clear to all of you now? Okay. So I'm moving on to the next question. I'm assuming that you are all understanding this one. Next one is again directly related to the formula, which is given in your theory part. The density is to be calculated in gram per ml. Okay. And molarity is given. It is 3.60. Then one thing more is given, which is percentage weight or percentage strength by weight of H2SO4, which is 29. And you have to calculate the density. The molar mass is also given for sulfuric acid, which is your solute, as 98 gram per mole. What will be the density of the solution? This is again a directly formula based question. Let me tell you the formula. 10 into percentage weight of your solute multiplied by the density divided by the molar mass. Sorry, multiplied by the density divided by the molar mass. So this is your molarity formula. You can just rearrange it to get your answer. I already said about it in the theory part. So please use that one to calculate the density directly from there. So what will be the answer? Solve it quickly. Come on. Quickly solve this question. And if you have a doubt, you can ask it now. Is it clear? Anyone who got the answer? What will be the answer to this question? Okay, so I'm assuming that you didn't note down the formula. So let me solve it for you. The correct answer will be 1.22. So moving on to the solution. This is the direct formula. Molarity is equals to 10 into density into percentage weight of solute divided by the molecular weight of the solute. So I have shown you this formula in the theory part also. If you just go, if you want, you can go back and see there. Then if you just rearrange it for density, it will be 3.60 into 98 by 10 into 29, because molarity is given here 3.6, density is given here 29, sorry, mass percentage is given here 29, or strength by strength of the solute in mass form, and the molecular weight is given here 98. If you put all of this, you will get this as 1.216 gram per ml, and you can just round it off to write it as 1.22 gram per ml. So have you seen this formula in the theory part? Do you remember this formula? Did I show you? And if yes, did you get the answer? So please calculate it. Are you getting the same answer, 1.22 gram per ml? Okay. No worries. If you are still putting the values, it's great enough. Okay. So since it is a crash course, I have to move faster. If you are knowing the formula, if you put the values, that is great enough, but try to be more faster. Now you have to decide that what is the molarity of solution formed by mixing 750 ml of 0.5 molar HCl with 250 ml of 2 molar HCl. Now this is solved by using a formula directly. So you have to follow it along with me. I have not shown this formula to you. First of all, you have to multiply m1 with v1 plus m2 into v2, where m1 and v1 are molarity and volume of the first solution, and m2 and v2 are the molarity and volume of the second solution. So you are mixing two solutions, and you have to tell that what is the molarity of the resulting solution. Then what will be the total volume? Of course, it will be the volume of the first plus the volume of the second. What is the formula to calculate? In that case, it is m is equals to m1 v1 plus m2 v2 divided by v1 plus v2. You put these values, 0.5 into 750 plus 2 into 250 divided by 1000. So that will give you 0.875. Okay. So this is your answer. Now let me give you a similar question regarding this. In this case, we are dissolving 10 milliliter of 2 molar NaOH with 200 milliliter of 0.5 molar NaOH solution. So what you have to calculate the final concentration. Remember, you have to use that same formula. So please calculate it and tell me the answer. What will be the final concentration? So what will be the final concentration? If you want rationalization of this formula, I can give you. So why are we doing this? Why are we multiplying m1 v1 plus m2 v2 by v1 plus v2? It's very simple. When you multiply the molarity with the volume, you get the number of moles. So you get the number of moles for the first. Similarly, you get the number of moles of the second. Then you are adding. So you are adding m1 v1 plus m2 v2. In a way, you are adding the number of moles of 1 with the number of moles of 2. And you are dividing it by the total volume. So that is basically your molarity. That is the way to calculate the molarity, volume of number of moles of solute divided by the volume of solution in liter. Got it? So this is the way you are forming the whole formula. So quickly just put the values and tell me what will be the answer for this question. Anyone who got the answer? Okay, so I'm already seeing answer. It is 0.57. Many of you are attending the class. I hope you are 5 and 6 of counting. So please give the answer. I have already said you the operating formula. And I said you the logic behind it as well. So what will be the answer? Okay, so I am seeing one more support in this 0.57. Anyone else who has a different answer from this? Okay, let's see the answer. So the correct answer will be A, 0.57. Very good. So it's very simple. We have looked upon a similar question. The final formula which will be used is your m1 v1 plus m2 v2 divided by v1 plus v2. So 10 into 2 plus 200 into 0.5 divided by 200 plus 10. If you calculate it, it will be 100 plus 20 by 210 is equals to 120 by 210, which is approximately 0.57. Easy. Moving on to the next question. Next question is, the density of a solution prepared by dissolving 120 gram of urea in 1000 gram of water is 1.15 gram per ml. The molarity of the solution is. So 4 options are given here. How you will solve it? Remember, you have to calculate the molarity. The density is already given there in the question. So please try it by yourself. How you will solve it? If you want, you can use the formula directly, which is 10 multiplied by the percentage weight of your urea. So that will be 120 by 1000 into 100 multiplied by the density, which is 1.15 gram per ml, divided by the molar mass of your urea, which is given 60 U. So that will directly give you the molarity. The same formula which you have used in the previous one, I guess in the second or third question, you have to use that same formula here also. Only one step is being mixed here. You are not given directly the percentage weight, you have to calculate it. And it's a easy one to do. You can easily calculate the percentage weight of urea. It is 120 by 1000. So just try to put all the values and tell me the answer. What will the answer for this question? I'm already seeing answer as D. Anyone else? Very good, BK. Okay, so one more answer, D. So all of you are getting D, or is there a different answer from D? So Partham, are you there? Are you attending my class? So can you please tell me the answer? Rithi or Shinjay, are you getting answer? Anyone else who got the answer? Again, I am telling you the formula. It is 10 into percentage weight of solute, which will be 120 by 1000, multiplied by the density, which is 1.15, whole divided by the molar mass of the solute, which is 60 U. Okay. So I'm moving on to the answer. The correct answer will be D, which is 2.05. So all of you are correct. Now, how we'll solve it? First, the total mass of the solution is 1120 gram. The density of the solution is 1.15 gram. So it is solved in a different way. We are not using the formula directly here. We are using a logical approach. It can be solved in this way also. So first, the volume is calculated using the density. Got it? Then further, the moles of solute will be what? It will be 120 by 60. It is given here that 120 dissolved in 1000 gram. So the number of moles of solute is 2. Next, you know the volume, you know the moles, you can calculate it here. Or else you can directly use our shortcut formula. It will give you the same answer. Okay? Is it clear to all of you? This approach is also a logical one. You can apply this one also, or you can use the formula directly. Both things are good to go. It matters which one is suiting you. Okay. So we are moving on to the next one. It is given here. The density of 3 molar solution of sodium chloride is 1.252 gram per ml. What will be the molality of the solution? The molar mass of NaCl is already given. So again you have to use the first formula, m into d, that one. You have to calculate what? The molality, and your molarity is given and the density is given, as well as the molar mass of NaCl is given. So we have seen a formula similar to this, which can be used here. So the first question was related to this one. Anyone else? What will be the answer? Rithi, Sri, Dhruv, VK, just try to calculate it quickly. So just be with us. We will try to solve each and every chapter. If you have a problem regarding previous chapter, you can just quickly come to our doubt clearing session, which goes from 10 to 6. You can ask questions here. I or my colleagues will try my best to answer your question. Okay? If you have a doubt from previous chapters. So anyone who is getting the answer? So this was asked in JEE Main 2013. Remember, questions are repeated from past 10 years also. It is not only repeated from recent year. It can be repeated from past 10 year also. So what will be the answer? Anyone who got the answer? You have to use the first question number 1 formula. That same formula is being used here. I will wait for 1 more minute. Okay, so I'm seeing answer C, 2.79 m. Anyone else? Dhruv, Patham, Rithi, Sinjay, anyone who is getting answer? Or anyone else? All of you who are taking the class can just reply to it. So this is a direct question from the formula. Okay, so I'm moving on to the answer now. Is anyone still calculating, or you are not remembering the formula? Are you calculating? Okay, so I will now move on to the solution. Just look how I have put it in the way. If you are putting it in the same way, then very good. Okay, so the correct answer will be C, which is 2.79. Now, let us move on to the solution. So, Partham, I will suggest you, so please be in the class. So, 3 molar solution means 3 moles of solute are present in 1000 ml of solution. So, I will give you a different approach to solve the same question. So, what will be the mass of solution? Either you can use the previous formula also, or this way also, whichever way you want. Okay, both are good. So, first what we did, we calculate the mass of the solution by multiplying volume and density, which will be 1252 grams. Then after, we calculate the mass of solute. Very simple, number of moles into molar mass of the NaCl. Why we are taking it a number of moles? Because in the question itself we are saying that 3 molar solution contain 3 moles of solute in 1000 ml of solution. So this is the basic meaning of the molarity. So from that we are taking the number of moles as 3, and further we are calculating the mass of the solute as 175.5. Got it? So now we need the now we know the mass of the solution and the mass of the solute. Next, what will be the mass of solvent? It's very simple. Just simply subtract it. You will get the mass of the solvent. Now, if you know all of the things, you can simply calculate molality, which is moles of solute divided by mass of solvent in kg, and moles of solute was 3 and mass of solvent is 1.076 kg, which is 2.79 molal. Okay, is it clear to all of you? Moving on to the last questions of today's class. It says that a 5.2 molar aqueous solution of methyl alcohol CH3OH is supplied. What is the mole fraction of the methyl alcohol in the solution? So 4 options are given here. So we are lacking time, so I will move on to the solution quickly. If you want, you can solve it along with me, or else you can just focus it here. 0.086 will be your correct answer. Let's see how we can solve it. So first of all, molality is equals to moles of solute divided by the mass of solvent in kg. Then from here you will get the number of moles. It's very simple, which is resolved in 1000 gram. Then further, since this 5.2 mole is dissolved in 1000 gram, you can calculate the number of moles of your water from here, which is 1000 by 18. So we can say that 55.56 is the moles of water, or you can also say it in a way that 5.2 moles of methyl alcohol is dissolved in 55.56 moles of water. Now why are we taking water here? Because it is said in the question that it is a aqueous solution, and in aqueous solution the solvent will be of course your water. Next, what is the total number of moles? 5.2 plus 55.56, which is 60.76. Finally, we can calculate the mole fraction of methyl alcohol, which is 5.2 divided by 60.76 is equals to 0.086. Is it clear to you? Anyone with a doubt in this question? So this was all for today's class. If you have a doubt, you can ask it just now. We'll start our maths class in a short while. So is there any suggestion for me or the class? Can we improve it in a way? You can just write your suggestions also in the comment section. Or this is good enough. So Partham, VK, Dhruv, Rithi, Sanjay, is it clear to all of you? Any doubt for today's class? Okay. So I hope all of all of you are getting my point. So tomorrow we will discuss mainly the colligative properties related to this, right? And then we will move to the equilibrium. Thank you. So I will see to it in a way I can resolve this thing, the lag between the user and your and
Hello everyone. Am I audible to you? Hello everyone. Am I audible to you? So welcome to 40 days JEE JEE lecture series course. So today our chapter is permutations and combination, and this is our day 10. Okay. So first we will discuss permutations and combinations theory part. Okay. And then we will discuss permutations and combinations question part. Okay. So let's start theory part first of all. Okay, this is our disclaimer. So first of all we will see what is the weightage of this chapter. Okay, so what is the importance of this chapter in the point of view of JEE exam. Okay, that first we will see. So you can see average one question has been asked in each year. Okay, if you see from 2017 to 2024, then you can see average one question has been asked in each year, and weightage of this chapter is 4.26 percentage. Okay, and this is very important point of view of JEE exam. Okay, now we will see in which topic, okay, from which topic, and we will see number of questions asked from this chapter. Okay, and we will see difficulty level. Okay, so if you observe here in 2024, so in 2024 number of questions asked in JEE exam is 1. Okay, and what is the difficulty level? Difficulty level is average. Okay, so you can solve this type of question from this chapter. Okay, very easy question asked in previous year. So don't miss this chapter. Okay, read this chapter very carefully. Okay, and solve many questions. Okay, and in 2023 you can see number of questions asked is 1. Okay, number of questions asked is 1 and difficulty level is average. Okay, and this one question asked based one fundamental principle of counting. Okay, and then in 2022 number of question asked 2. Okay, and difficulty level is average. So very important chapter this is. Okay, you can easily solve by using some properties, okay, and some formula of this chapter. Okay, so this question, okay, these questions are two questions based one fundamental principle of counting. Clear? Then if you see in 2021, so in 2021 number of questions asked is 2. Okay, and difficulty level is average, and these questions based one fundamental principle of counting. Okay, or permutation and combination. Okay, as you know all, fundamental principle of counting, there we have two types of fundamental principle counting. First one is addition principle and second one is multiplication principle. Okay, based on this topic in 2021 two questions asked in JEE exam. Okay, difficulty level is average. Clear? Then see in 2020, okay, number of question asked 1, difficulty level average. Okay, and this question based one permutations. Okay, simply permutations, and you can easily solve this question. Okay, in 2019 number of question asked 1 and difficulty level average and topic combinations. Okay, and in 2018 number of question asked 1, difficulty level average. Okay, and best one permutations. Okay, and in 2017 number of question asked 1 and difficulty level difficult. Okay, only in 2017 difficulty level is difficult. Okay, but in other years you can see difficulty level is average. So on average difficulty level question asked from this chapter. Okay, and these questions best one combination, permutations, okay, and fundamental principle of counting, this one. Clear? So I hope trend analysis is clear to all of you. Okay, now moving to the index. Okay, so which topic will be covered in this lecture? First we will see. Okay, so students, see here, first we will discuss fundamental principle of counting. Okay, as we told you, there are two types of fundamental principle of counting. Okay, first type is multiplication principle and second type is addition principle. Okay, that we will discuss in later. After that we will discuss factorial notation. Okay, and then we will discuss permutations. Okay, so there we will discuss what is permutation, what is the useful of permutations. Okay, why permutation is very important, that we will discuss. And then we will see some properties of NPR. Okay, so there we will see some properties of NPR. Okay, and we also know the formula of NPR. So simply if you know the formula of NPR and if you know properties of NPR, then so many questions you can solve from this chapter. Okay, so this chapter is very easy chapter, so do it. Okay, and then we will discuss important results on permutations. Okay, so there are some important results on permutations. We will talk about these important results on permutations. These important results will help you to solve many questions. Clear? So I hope you are ready to start. So first, look at fundamental principle of counting. So first we will talk about fundamental principle of counting. Okay, so focus one here. So the fundamental principle of countings is a way to figure out the total number of ways in which different events can occur. Okay, suppose a certain work A can be done in m ways and another work B can be done in n ways. Okay, then we have two fundamental principle of counting. First one is addition principle and second one is multiplication principle. So first we will see addition principle. Okay, so what said addition principle? So the addition principle says if a certain work A can be done in m ways and another work B in n ways, okay, then the number of ways of doing the work C which is done only when either A or B is done. Okay, you have to focus here, either A or B is done. Okay, so in how many ways of doing the work C which is done only when either A or B is done? This is m plus n. Okay, so m is what? M is if a certain work A can be done in m ways. Okay, m basically number of ways a certain work A can be done. Okay, and n is basically the number of ways in of a certain work B can be done. Okay, and if we then add m and n, so if we add m and n, then you will get the number of ways of doing the work C which is done only when either A or B is done. Okay, and this principle is called addition principle. Okay, note this point, this principle is called addition principle. Why this called addition principle? Basically we are adding here number of ways of number of ways of a certain work A can be done and number of ways of another work B in n ways. Okay, here we added them and we get the number of ways of doing the work C which is done only when either A or B is done. Okay, this is m plus n. Okay, clear? I hope this principle is clear. Clear it? Is it clear? is this principle clear? So in addition principle, what we do? Can you say in addition principle what we do? Okay, why we use addition principle? Okay, so you should keep in your mind when you say you are finding number of ways of doing the work C, which is done only either A or B is done. Okay, you can you have to focus here, either A or B is done. That there is number of ways of doing the work C is basically m plus n. Okay, m is here, then A can be done in m ways and another work B in n ways. Okay, this is addition principle. Now moving to the next principle. So what is that principle? Next principle is multiplication principle. Okay, so what said multiplication principle? If a certain work A can be done in m ways and another work B in n ways, then the number of ways of doing the work C, which is done only when both A and B are done. Okay, here you should focus on this point, both A and B. Okay, when you when question said you both A and B are done, that case you should use multiplication principle. Okay, when question said either A or B is done, that case you should use addition principle, that is m plus n. Okay, so understand when you have to use addition principle and when you have to use multiplication principle. Okay, so when you are given a certain work A can be done in m ways and another work B in n ways, then the number of ways of doing the work C, which is done only when either A or B is done, is m plus n. Okay, and then the number of ways of doing the work C, which is done only when both A and B are done, is basically m times n. Okay, so these two principles are very important principle. Based on these two principle, there in JEE exam many question asked. Okay, so you should keep in your mind these two principle. Okay, these are two fundamental principle of counting. Okay, clear? I hope this is clear to all of you. Okay, now moving to the next. Now we will talk about factorial notation. So do you know about factorial notation? Do you have any idea about factorial notation? You can write in chat section if you have any any idea about factorial notation. Okay, so previously you have studied about factorial notation. So what is factorial notation? Do you know? So first we will see definition of factorial notation. Okay, so what is factorial notation? Factorial notation is basically the product of first n natural numbers. Okay, so you have first n natural numbers 1, 2, 3, 4, 5, 6, 7 and so on and n. Okay, so you have n first natural numbers. So if we product them, then you will get factorial n. Okay, so here you can see this notation, factorial n. Okay, this is called factorial n. This read as factorial n. So factorial n is basically the product of first n natural numbers. Okay, clear? So this is the definition of factorial notation. And factorial notation, we will use this notation in permutations and combinations both. Okay, so you should clear your clear this topic. Okay, you should clear your concept on this topic. What is factorial notation? What are the properties of factorial notation? Okay, you should know. Okay, so the product of first n natural numbers is denoted by factorial n, read as factorial n. Thus factorial n is basically product of first n natural numbers. Okay, so can you say first n natural numbers? Can you write in chat section? Factorial n is basically product of first n natural numbers. So you all know about natural numbers. Okay, so natural numbers started from 1, then next number 2, then 3, 4, and so on. Okay, and here we are taking n natural numbers. Okay, so if we product them, okay, that means if we take n times n minus 1 times n minus 2 times dot 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 3 times 2 times 1, okay, then what you will get? Then you will get factorial n. Okay, so factorial n equals n times n minus 1 times n minus 2 times dot 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 3 times 2 times 1. Okay, so can you find factorial 2? Okay, so everyone try it yourself. What is factorial 2? Okay, write your answer in chat section. What is factorial 2? What does mean factorial 2? Factorial 2 means what? So factorial 2 means you are taking product of two natural number. So uh, first two natural number. Okay, so we have first two natural number basically 1 and 2. Okay, so if we take product 2 and 1, then you will get factorial 2. Okay, similarly try to find factorial 3. Okay, what is factorial 3? Can you write it? So what is factorial 3? Factorial 3 means the product of first three natural numbers. So which are the first three natural numbers? First three natural numbers are basically 1, 2 and 3. Okay, so find product of first three natural numbers, then what you will get? So if we find product of three natural numbers, first three natural numbers, then you will get 3 times 2 times 1. Okay, that is basically 6. Clear? So factorial 3 equals 6. Can you find factorial 4? This is very simple. Okay, similar in similar process you can find factorial 4. Okay, what is factorial 4? Can you say what is factorial 4? So factorial 4 is basically the product of first four natural numbers. Okay, so which are the first four natural numbers? They are basically 1, 2, 3, 4. Okay, so if we take product of first four natural numbers, then you will get 4 times 3 times 2 times 1, that is equals 24. Okay, so factorial 4 equals 24. So now find factorial 5, factorial 6, factorial 7, factorial 8, factorial 9 and factorial 10. Okay, so after factorial 10 you should remember, okay, that will help you to simplify any question in JEE exam. Okay, so you should keep in your mind factorial 1, factorial 2, factorial 3, factorial 4, factorial 5, factorial 6, factorial 7, factorial 8, factorial 9, factorial 10 and so on. Okay, so I hope this concept is clear to all of you. Now moving to the next. Now we will talk about properties of factorial notation. Okay, so there are some properties of factorial notation that we will discuss. Okay, so you should note this point: factorial 0, factorial 1. Okay, this is equal to 1. Okay, so product there is no natural numbers. Okay, 0 is not natural number. Okay, but you can say here factorial 0 is 1. Okay, and factorial 1 is 1 also. Okay, so note this property of factorial notation. This property will help you to solve many problems. Okay, and the second property is factorials of negative integers. So what are the negative integers? Like minus 1, minus 2, minus 3, minus 4, minus 5 and so on. These are basically negative integers. Can you find factorial of these negative integers? Okay, so can you find this factorial of negative integers? Do you know about factorials of negative integers? Do you know factorial of minus 2? Do you know factorial of minus 1? Do you know factorial of minus 3? Okay, so factorial of negative integers. Okay, and you can say factorials of fractions. Fractions means 1 by 2, 2 by 3, 3 by 5, okay, and so on. Okay, this type of numbers are called fractions. So factorials of negative integers and fractions are not defined. Okay, so you should keep in your mind factorials of negative integers and fractions are not defined. You cannot define factorial of negative integers and fractions. Okay, that means factorial of -2 is not defined, factorial of -1 is not defined, factorial of -3 is not defined, factorial of -5 is not defined. Okay, and factorial of 1 by 2, factorial of 2 by 3, factorial of 3 by 5, okay, these are not defined. So you should note this point: factorial of negative integers and fractions are not defined. Clear? Now move to the next property. So next property is factorial of n equals n times n minus 1 factorial. Okay, so you can write simply factorial n as n times n minus 1 factorial. Okay, and this also can be written as n times n minus 1 times n minus 2 factorial. Okay, so this is very important property of factorial notation. So factorial n equals n times n minus 1 factorial, and this is equal to n times n minus 1 times n minus 2 factorial. Okay, so easily you can find 5 factorial as 5 times 4 factorial. Okay, so 5 factorial can be written as 5 times 4 factorial, and you will know the value of 4 factorial is 24. So easily you can calculate 5 factorial equals 5 times 24. This is equal to 120. Okay, similarly you can find factorial of 6. Okay, so factorial of 6 is basically 6 times 5 factorial of 5. Okay, and you already found factorial of 5 is 120. Okay, so 6 factorial equals 6 times 120. This is equal to 720. Okay, so by using this property you can easily find the next factorial of the number if you know the previous factorial of number. Okay, so note this property. This is very important property. This property will help you to simplify many expression, difficult expression. Okay, so factorial n equals n times n minus 1 factorial. This is equal to n times n minus 1 times n minus 2 factorial. Okay, clear? I hope this is clear. Now moving to the next property. So in next property here we have factorial n divided by factorial r. This is equal to n times n minus 1 times n minus 2 times dot 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 r plus 1. Okay, so how we obtain here? So you can write by using the previous property, that is factorial n equals n times n minus 1 factorial. Okay, so if you using this property, then you can write factorial n as n times n minus 1 times n minus 2 times dot 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 r plus 1 times r factorial. Okay, you can write this, and then if we cancel factorial r in numerator and denominator, then you will get factorial n divided by factorial r equals n times n minus 1 times n minus 2 times dot 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 r plus 1. Clear? So this is also very important property. So note these 4 properties. These are very important properties of factorial notation. These properties will help you to solve many problems. Okay, so you should keep on your mind these properties. Clear? So note these properties: factorial 0 equals factorial 1 equals 1, and factorial of negative integers and fractions are not defined. And the third property, factorial n equals n times n minus 1 factorial, and this is equal to n times n minus 1 times n minus 2 factorial. Okay, and the fourth property is factorial n divided by factorial r equals n times n minus 1 times n minus 2 times dot 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 r plus 1. Okay, clear? I hope this is clear. Are you getting my point? So if you have any doubt, then you can ask. Okay, do you have any doubt? Everything is clear? I think every concept are clearing. Okay, basically these are very simple properties. Okay, and you've already studied about these properties in class 11. Okay, so these are very simple properties, so you will know about these properties, and I hope these properties are clear to all of you. Okay, now moving to the next. Now we will talk about permutations. Do you know about permutations? Do you have any idea about permutations? What is permutation and why we use permutation? Do you know about this? So if you know, then you can write in chat section. Okay, what is permutation, how we find permutation of numbers, okay, and how we use permutation and why we use permutation. Okay, so that you should know. Okay, these are some basic concepts, okay, basic things, but you should know for clearing your concept. What is permutation? Why you use permutation? What is important of permutation? Okay, and why how we solve problems on permutations. Okay, you should know about that. So what is permutation? So permutation means arrangement of things. Okay, so you have many things. Okay, suppose you have 4 bags. Okay, and 4 different colors. Okay, so you are arranging them. Okay, so you can use for that permutation. So permutation means arrangement of things. Okay, you have so many things, you want to arrange them. That case you use permutation. So permutation means arrangement of things. Okay, and how if what actually mathematical meaning of permutation? So the number of permutation of n different things taken are at a time, is NPR. So permutation means you were arranging different things from n different things. Okay, so the number of permutation of n different things taken are at a time. Okay, so you have n different things, and you are taking r things at a time. Okay, and this is NPR. Clear? So the number of permutation of n different things taken r at a time is NPR. Okay, now we will talk about the formula of NPR. Do you know the formula of NPR? Do you know what is the formula of NPR? Do you know? So here what is NPR? NPR basically number of permutations of n different things taken are at a time. Okay, so we will now see the formula of NPR. Okay, here you can see the formula of NPR. NPR means the number of permutations of n different things taken are at a time. Okay, means you have n different things, and you are taking r things at a time. Okay, that case you find NPR. Okay, so NPR equals basically n times n minus 1 times n minus 2 times dot 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 n minus r plus 1. Okay, this is actually NPR. Okay, so this is the formula of NPR, and you can write this formula in this form also: n factorial divided by n minus r factorial. How we obtain it? Actually here, if you multiply and divide by n minus r factorial, okay, and then if you use the properties of factorial notation, that is n factorial equals n times n minus 1 factorial, okay, equals n times n minus 1 times n minus 2 factorial. Okay, so if you use this property, and if you multiply and divide by n minus r factorial, then you will get NPR equals factorial n divided by n minus r factorial, where 0 less than equal to r less than equal to n. So what is the range of r? Here r must be lies between 0 and n. Okay, so 0 less than equal to r less than equal to n. So NPR, so for note this formula, NPR equals means NPR n factorial divided by n minus r factorial. So if I give you to find 3p2, so what is the value of 3p2? So everyone try it yourself. Okay, so write in chat section what is 3p2. Okay, so using this formula, and you have to find 3p2. This is very simple, easily you can find 3p2. Okay, so find it, everyone find it, do it, everyone try it. Very simple. Okay, just you have to find 3p2. Okay, you know the formula NPR equals factorial n divided by n minus r factorial. Okay, so 3p2 is basically what? 3p2 is basically 3 factorial. Okay, here the value of n is 3. Okay, and the value of r equals 2. Okay, so substitute here the values of n equals 3 and r equals 2. Okay, and then use properties of factorial notation, then you will get 3p2. Okay, so 3p2 equals 3 factorial divided by 3 minus 2 factorial. Okay, so 3 minus 2 factorial is 1 factorial, that is 1. Okay, so NPR equals 3 factorial. Okay, and 3 factorial is basically 6. Okay, so good, your answer is correct. 3p2 is 6. Now try to find 5p4. Okay, find 5p4. Okay, try it yourself, try it by yourself. Okay, and write this, write the answer in chat section. So what is 5p4? So using this property and find 5p4. What is the value of 5p4? So first, you have to when if we are finding the value of 5p2, okay, 5p4. Okay, so that case first you have to identify the value of n and the value of r. Okay, and you in your mind you will have the formula n pair, that is equals n factorial divided by n minus r factorial. Okay, so in this formula just you have to substitute the value of n and the value of r. Okay, so n is here 5, okay, and r is here 4. So 5 factorial upon 5 minus 4 factorial, this is equals 120. Good, your answer is correct. 120 is correct answer for 5p4. Excellent. Now I hope this is clear to all of you. Okay, so do you have any doubt on this slide? So if you have any doubt, then you can ask. Okay, otherwise we will move to the next. Do you have any doubt? Please ask your doubt if you have. This is very simple. I hope you have no doubt. Okay, so this is actually a definition of permutation, and here we studied the formula of NPR. Okay, this is very crucial formula. Okay, and this formula we will use in our problem solving course when we will solve questions. Okay, now moving to the next. So here now we will talk about properties of NPR. So there are some properties of NPR that we will discuss now. Okay, so first property is NP0 equals 1, NP1 equals n, NPn equals factorial n. So first of all, try it how we obtain NP0 is 1, and try it do it yourself. NP1 is yn, okay, and ynpn equals factorial n. Okay, so here this is very simple. Why? Because here just we can use the formula of NPR. Okay, so you well know the formula of NPR. This is actually NPR equals n factorial divided by n minus r factorial. Okay, so by using this formula you can find why NP0 is 1, okay, and why NP1 is n, and why NPn is factorial n. So I hope you you will try to find NP0, NP1 and NPn. Okay, so NP0 is simply equals n factorial divided by n minus 0 factorial. Okay, so n factorial divided by n minus 0 factorial, this is actually equal to n factorial divided by n factorial. Okay, this is equals 1. So NP0 equals 1. Clear? And then similarly you can find NP1. So NPn is what? So NP1 equals basically n factorial divided by n minus 1 factorial. Okay, now you have to find an important property, that is n factorial equals n times n minus 1 factorial. Okay, do you know do you know this property? So we've already talked about this property. Okay, so you will note this property. So n factorial equals n times n minus 1 factorial. Okay, so now you can write np1 equals n factorial divided by n minus 1 factorial, and you can write factorial n as n times n minus 1 factorial. Okay, so n times n minus 1 factorial divided by n minus 1 factorial, this is simply equals n. Why? Because here n minus 1 factorial and n minus 1 factorial will be cancelled to each other. Okay, and you will simply get np1 equals n. Clear? And the next here are npn. So npn simply equals n factorial divided by n minus n factorial. Okay, and n minus n factorial is basically 0 factorial, and we already knows the properties of factorial notation. That is 0 factorial equals 1. Okay, so npn equals n factorial divided by 0 factorial. This is equal to n factorial divided by 1. Okay, this is equal to n factorial. So npn equals factorial n. Clear? So this is our first property of NPR. Now we will discuss next property. So the next property is NPR plus R times NPR minus 1 equals N plus 1 PR. Okay, this is very crucial property of NPR. Okay, so we frequently use this property to solve many problems, one permutations and combinations. Okay, so note this property: NPR plus R times NPR minus 1 equals N plus 1 PR. Okay, so you can prove it. Okay, so you can start from LHS, okay, and then you can show RHS. So you can do it by yourself. Okay, so do it by yourself. How you can show NPR plus R times NPR minus 1 equals N plus 1 PR. Clear? Now we will see next property. The next property is NPR equals N times N minus 1 PR minus 1. Okay, this is the third property of NPR. Okay, this is also very crucial property. Okay, when we simplify any problems one based on NPR, that case you use this property. Okay, so NPR equals N times N minus 1 PR minus 1. Okay, you can easily prove this by using the definition of the formula of NPR, that is equals N factorial divided by N minus R factorial. Clear? Now we will see next property. So in next property here we have NPR. Okay, NPR equals N minus R plus 1 NPR minus 1. This is a very important property also. Okay, and the fifth property is N minus 1 PR equals N minus R N minus 1 PR minus 1. Okay, you can easily prove these all the properties of NPR easily. Okay, by using the formula NPR equals factorial N divided by N minus R factorial. Clear? So I hope this is clear. So do you have any doubt about this slide? If you have any doubt, then you can ask. So these are some important properties, so you should keep in your mind these properties. Okay, so now moving to the next. So now we will discuss some important results one permutations. Okay, so there are some important results one permutation. These are very important properties on permutations. Okay, so you should focus on these results on permutations. Okay, so here you can see first result. So in first result here we have the number of permutations of n different things. Okay, suppose you have n different things and you are taken r at a time. Okay, when a particular thing is to be always included. So one particular thing has to be always included. That case we have to find we can find number of permutations of n different things taken r at a time is r times n minus 1 p r minus 1. Okay, so here this is the number of permutations of n different things taken r at a time when a particular thing is to be always included. Okay, so note this point here, a particular thing is to be always included. So you are actually taking you are arranging n different things taken r at a time, and you are taking a particular thing always included. Okay, so that case the number of permutations is r times n minus 1 p r minus 1. Clear? I hope this is clear. The next results is basically a number of permutation of n different things taken are at a time when a particular thing is never taken. Okay, so in this result here we are not taking a particular thing. Okay, so that case the number of permutation of n different things taken are at a time is n minus 1 pr. Okay, so you should keep in your mind the number of permutations of n different things taken are at a time when a particular thing is never taken in its arrangement. Okay, and the next result is the number of permutations of n different things taken are at a time, here allowing repetitions. Okay, so here you can take any things more than one time. Okay, so here repetitions are allowed. Okay, that case the number of permutations of n different things taken are at a time is n to the power r. How? Here when you take n different things taken are at a time. Okay, so you are allowing repetition, so you can take every things n times. Okay, you can take you can here you can find the number of permutation of n different things taken r at a time is n to the power r. Okay, you can write n times n times n times n times, that is r times. Okay, so that is n to the power r. When this happen, when repetition is allowed. Okay, and the fourth result is the permutations of n things of which p are identical of one type, q are identical of second type, and r are identical of third type is basically factorial n divided by p factorial times q factorial times r factorial. And here you should note this point: p plus q plus r equals n. Okay, so you have n things. Okay, among these n things, p things are identical of one type. Okay, q things are identical of second type, and r things are identical of third type. Okay, then if you ask you number of permutation of n things of which p are identical of first type, q are identical of second type, and r are identical of third type, then what is the permutation? So the answer is factorial n divided by p factorial times q factorial times r factorial, where p plus q plus r equals n. Okay, note this, clear this point. I hope this is clear. Okay, so if you have any doubt, then you can ask freely. Okay, so ask your doubt if you have. So I hope these results are clear. Now we will see some more results, one permutations. Okay, so now we will discuss about arrangements. So in arrangement, number of ways in which m different things and n different things, okay, where m plus 1 is greater than equal to n can be arranged in a row. Okay, so you have a row, okay, and you are arranging m different things and n different things. Okay, and where m plus 1 is greater than equal to n. Okay, that case here we have condition so that no two things of second kind come together. So there will not come two two things of second kind. Okay, that case the number of ways is factorial m times m plus 1 pn. Okay, this is the number of ways in which m different things and n different things where m plus 1 is greater than equal to n can be arranged in a row so that no two things of second kind come together. Clear? I hope this is clear. And the next result is number of ways in which m different things and n different things. So you have m different things and n different things, and here m is greater than equal to n. Okay, so in previous one we have m plus 1 is greater than equal to n. In this result we have m is greater than equal to n. Okay, so number of ways in which m different things and n different things can be arranged in a row so that all the second type of things come together. Okay, so in this case all the second type of things come together, but in previous result we have seen no two things of second kind come together. Okay, but in this case all the second type of things come together. Okay, that case the number of ways in which m different things and n different things where m is greater than equal to n can be arranged in a row is m plus 1 factorial times n factorial. Okay, clear? I hope this is clear. Now we will see about dearrangement. Okay, so the dearrangement means what? Dearrangement means no object goes its scheduled place. Okay, so if we have n envelope, okay, so e1 e2 e3 up to en, these are n envelope. Okay, and we are talking here no letters will goes their correct envelope. Okay, so that case we use dearrangement. Okay, so the form here we have the formula of dearrangement. So the number of dearrangements of n objects is factorial n times 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus dot 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 minus 1 to the 4 n times 1 by 1 by n factorial. Okay, so this is the formula of number of dearrangements of n objects. Okay, so note this formula: number of dearrangements of n objects That means no object goes to its scheduled place is factorial n times 1 by factorial 2 minus 1 by factorial 3 plus 1 by factorial 4 minus dot 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 minus 1 to the power n times 1 by factorial n. Okay, clear? Got it? And the next result, sum of digits. Okay, so first first part of this result is basically sum of numbers formed by taking all the given n digits. Okay, here we excluding 0. Okay, that is that case the sum of numbers is sum of all the n digits. Okay, you have n digits and just you have to take sum of n digits. Okay, all the n digits, then you have to multiply n minus 1 factorial, then multiply 111 n times. Okay, so this is the sum of the numbers formed by taking all the given n digits excluding 0. Okay, note this point, excluding 0. We are not taking 0. That case sum of numbers formed by taking all the given n digits is sum of all the n digits times n minus 1 factorial times 111 and dot 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 n times. Okay, and the second part of this result, okay, sum of the numbers formed by taking all the given n digits. Okay, so you have n digits. Okay, and here you are including also 0. Okay, you are also including 0. That case the sum of the numbers formed by taking all the given n digits is sum of all the n digits. Okay, times n minus 1 factorial times 111 and n times. Okay, minus n minus 1 times 1111 n minus 1 times. Okay, this is the formula of sum of the numbers formed by taking all the given n digits including 0. Okay, so you should focus here these 2 points, excluding 0 and including 0. So for excluding 0, the number sum of numbers is basically sum of all the n digits times n minus 1 factorial times 1111 n times. Okay, and when you are including 0, then sum of the numbers formed by taking all the given n digits is sum of all the n digits times n minus 1 factorial times 1111 n times. Okay, minus n minus 1 times 1111 n minus 1 times. Okay, so these are some important results when permutations. These are very important properties. Okay, these are very important results, and these results will help you to solve many problems in the point of view of JEE exam. Okay, so next we will discuss practice questions on this chapter. So students, first of all, look at here the first question. Okay, so in first question here we have to find the value of 2 to the power n times 1 times 3 times 5 times dot 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 2n minus 3 times 2n minus 1. Okay, so you have here the expression 2 to the power n times 1 times 3 times 5 times dot 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 2n minus 3 times 2n minus 1. Okay, and then you have given 4 options, so you have to choose the correct answer from the given options. So first of all, try it by yourself. Okay, and give your answer in chat section which option is correct. Okay, do it yourself first, take your time. Try it and give your answer in chat section which option is correct. Which option is correct? Which option? Try it by yourself, by yourself. Hint is you have to here multiply by 2 times 4 times 6 times dot 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 times 2n. Okay, one numerator and denominator. Okay, so using this hint, find the correct answer. Which option is correct here? Everyone, try it yourself and give your answer. Do it. Very simple. Okay, very simple. Easily you can do. Everyone try. Just we have to find the value of this expression. Okay, so you have the here given this expression, and then you have to find the value of this. So you have 4 options. Among these 4 options, which option is correct, that you have to find. So write your answer in chat section. Which option is correct? Try it. Very simple question in the point of view of JEE exam. You all can do it. Everyone try. Everyone do it. I hope you solve it. Okay. Now we will solve it step by step. So the correct answer is here option A. Okay. So option A here the correct answer. Now let's start the solution step by step. Okay. How can we solve this question? That now we'll see. So what you have given? You have given the expression 1 times 3 times 5 times dot 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 2n minus 3 times 2n minus 1 times 2 to the power n. Okay, so you have given simply this expression. Okay, and you have to find the value of this expression. So how can you find the value of this expression? So simply here multiply and divide the even numbers like 2 4 6 and 12. Okay, so then you will can write the given expression as 1 times 2 times 3 times 4 times 5 times 6 and dot 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 2n minus 1 times 2n times 2 to the power n divided by 2 times 4 times 6 times dot 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 2n. Okay, so then what we will do next? What approach you have to use now? Just you multiply and divide by 2 4 6 and 2n. Okay, and just you can use here factorial properties of factorial notation. Okay, so 1 times 2 times 3 times 5 times 6 times dot 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 2n minus 1 times 2n is simply 2n factorial. Okay, this is factorial of 2n. Okay, and in denominator you can common out 2 from each numbers. Okay, so if we common out 2 from each numbers, then actually you will get 2 times 2 times 2 times dot dot 2 n times. Okay, and you will get with multiplication 1 times 2 times 3 times dot dot n. Okay, so n 2 times 2 times 2 times n times, this can be written as 2 to the power n. Okay, so you can write in denominator 2 to the power n times 1 times 2 times 3 times 4 times dot 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 n. Okay, so now you can cancel 2 to the power n in numerator and denominator. Okay, so if we cancel 2 to the power n in numerator and denominator, then simply you will get factorial 2n divided by factorial n. Okay, and this is our final answer. So I hope this solution is clear to all of you. Okay, so if you have any doubt, then you can ask. Okay, so is it clear to all of you? Are you getting my point? How we solve this question? Can I say you again or not? Okay, please write in chat section. Is it clear to all of you? Simple, very simple. Okay, just we multiply by 2 times 2 4 5 6 2 6 2 4 6 and dot dot to n. Okay, in numerator and denominator, and then just simplify, we obtain the final answer. Okay, clear? I hope this is clear. Okay, now moving to the next question. So in this question we have given this expression 1 times factorial 1 plus 2 times factorial 2 plus 3 times factorial 3 plus dot 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 plus n times factorial n. Okay, this is given to us, and what we have to do, we have to find the value of this expression. Okay, and you have given here 4 options. So among these 4 options, which option is correct, that you have to find. So first of all, try it by yourself. Okay, so do it first and write your answer in chat section. Which option is correct? Take your time. Take your time and give your answer. Which option? Do it. Everyone, do it. Try it. Very simple question. Okay, just you have to identify pattern. Okay, and I'm giving you hint. You can write this expression, this given expression, as summation r times r factorial. Okay, from r equals 1 to n. Okay, using this hint, give your answer. Which option is correct? Everyone, try it. Which option is correct? Hurry up. Quickly, do it. Which option correct? Please try. So now we will solve this question step by step. So our answer is option C. Okay, so let's start the solution. So clearly given expression is summation r times factorial r. Okay, from r equals 1 to n. You can write the given expression as this summation form. Okay, and then summation from r equals 1 to n, r times factorial r, this is equal to summation from r equals 1 to n, r plus 1 minus 1 times factorial r. Okay, here we just manipulate. Okay, r plus 1 minus 1, right? And this is equal to summation from r equals 1 to n, r plus 1 factorial minus factorial r. Clear? Now just put the values from r equals 1 to n. Okay, then you will get factorial 2 minus factorial 1 plus factorial 3 minus factorial 2 plus dot 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 plus factorial n plus 1 minus factorial n. Okay, so you can cancel factorial 2 and minus factorial 2, and you can cancel factorial 3 and factorial minus 3. Okay, just you will will have remaining terms, that is n plus 1 factorial minus 1. Okay, so this is the value of the given expression, and this is our final answer. So I hope this is clear to all of you. Now moving to the next. Here in this question we are asking how many different 9-digit numbers can we form from the digits of the numbers 2 2 3 3 5 5 8 8 8. Okay, by a rearrangement of the digits, and we have given the condition so that the odd digits occupy even places. Okay, so first of all see like write 9 places. Okay, and among these 9 places you have to place odd digits in even places. Okay, how many even places are there and how many odd digits you have, first look at that point. Okay, so see here the options. You have 4 options. First of all, try it yourself and then see solution. Do it. Take your time and do it by yourself. Everyone, do it. Okay. Now we will solve this question. Answer is option C. Okay. So match your answer with correct answer. Here answer is option C. Let's start the solution. So you can see in a 9-digit numbers, there are 4 even places for the 4 odd digits. You have 4 odd digits 3, 3, 5, 5. Okay. So 4 even places you have and 4 odd digits you have. So you can place 4 odd digits in 4 even places. In how many ways? In factorial 4 divided by factorial 2 times factorial 2. Why? Because here 3 repeats twice and 5 repeats twice. Okay. So this is actually number of 9-digit number of ways we can place odd digits in the even places. Okay. And you have remaining 5 digit. Okay. Even digits you can say that are placed in odd places. Okay. So remaining 5 digits can be placed in how many ways? Factorial 5 divided by factorial 2 into factorial 3. Okay. So now the required number of ways is basically factorial 4 divided by factorial 2 times factorial 2 times factorial 5 divided by factorial 2 times factorial 3. Okay. This is the required number of ways. And if you simplify this, and then you will get 60. Okay. So our final answer is 60. Are you getting my point? I hope this is clear to all of you. Okay. Now moving to the next. So first of all, read the question very carefully. So what you have given? You have given A copies of one book, B copies of each of 2 books, C copies of each of 3 books. Okay. And single copies of D books. Okay. Then you have to find total number of ways in which these books can be arranged. Okay. So you have 4 options. So first of all, try it by yourself. Which option is correct? Write your answer in chat section. Okay, students. Now see the solution. So here the correct answer is option B. Match your answer with this correct answer. Okay, here correct answer is option B. So let's start the solution. So first find total number of books. So total number of books basically A plus twice of B plus 3 of 3 times C plus D. Okay, this is the total number of books. And then the total number of arrangements is basically total number of books divided by number of copies. Okay, so total number of books, total number of arrangements equals A plus 2B plus 3C plus D factorial divided by A copies of one book, that is factorial A divided by factorial A, and B copies of each of 2 books, so factorial of B whole squared, and C copies of each of 3 books, so factorial of C whole cube. Okay, and here single copies of D books. Okay, that is factorial of 1. So this is the total number of arrangements. So I hope this is clear and you are getting my point. So now moving to the next question. So what we have given? Here we have given the word article. Okay, and we have to find the number of words which can be formed out of the letters of the word article so that vowels occupy the even places. Okay, so here we have given 4 options. First of all, try it yourself and then see solution. So do it yourself first. Everyone, try it yourself. Very easy question. Very simple question. Okay, you can do it. Just you have to find the number of words. Okay, which can be formed out of the letters of the word article. so that vowels occupy the even place. Okay, first identify vowels here. So here you have vowels A, I, E. Okay, so here A, I, E occupy the even place, and we have to find the number of words. So let's see the solution. The correct answer is option B here. Let's start the solution. So here in a word article, we have A, E, I, these are vowels, okay, and C, L, R, T, these are consonants, okay. So in a 7-letter word, there are 3 even places in which 3 vowels are placed in factorial 3 ways, okay. In rest of the 4 places, 4 consonants are placed in factorial 4 ways, okay. So 3 vowels can be placed in 3 even places in factorial 3 ways, and the rest of 4 places, 4 consonants are placed in factorial 4. Clear? So therefore required number of ways is factorial 3 times factorial 4. Okay, factorial 3 is 6 and factorial 4 is 24. 6 times 24 equals 144. So this is the required number of ways. So this is the number of words which can be formed out of the letters of the word article, so that vowels occupy the even place. Okay, clear? I hope this is clear. Are you getting my point? So do you have any doubt? Then you can ask. Do you have any doubt? So if you have any doubt, then you can ask, otherwise we will move to the next. Do you have any doubt? Okay, I hope this is clear. So now moving to the next. In next question, here we have given the word arrange. Okay, and here we have defined in how many ways the letters of the word arrange can be arranged without altering the relative positions of vowels and consonants. Okay, so here we have given 4 options, so you have to choose the correct answer from the given options. So first of all, try it by yourself. Do it. Are you trying? Quickly do it. Which option is correct? Okay, so now we will see the solution. So our answer is option A. So match your answer with correct answer. Here the correct answer is option A. So let's start the solution. So clearly you can see the consonants in their positions can be arranged in how many ways? So consonants in their positions can be arranged in factorial 4 upon factorial 2. Okay, here you have 4 consonants. There are 4 consonants. They are R, N, G. Okay, and here R repeats twice. So 4 consonants can be arranged in their positions in factorial 4 divided by factorial 2 equals 12 ways. Okay, and here you have vowels A, E. Okay, 3 vowels are there. So these are vowels in their positions can be arranged in factorial 3 divided by factorial 2. Among these 3 vowels, here A repeats twice. Okay, this is why the vowels in their positions can be arranged in factorial 3 divided by factorial 2 equals 3 ways. Now total number of arrangements is 12 times 3. This is 36. Okay, this is the total number of ways the letters of the word arrange can be arranged without altering the relative positions of vowels and consonants. Clear? I hope this is clear. Okay, now moving to the next. Now here see what we have given. So here we have given the word Sachin. Okay, and here we have to write in dictionary order. So then we have to find the word Sachin appears at serial number. So what is the serial number of the word Sachin? That we have to find. So we have given a 4 options. So among these 4 options, which option is correct? That you have to find. So first of all, try it yourself. Okay, so do it yourself first and give your answer in chat section. Which option is correct here? Everyone, try it yourself. Do it. Which option? Give. Quickly, give your answer. Everyone try. Are you trying? Okay. Now we will solve this question. So our correct answer is option B. Okay. So let's start the solution. The letters of the given word are basically A, C, H, I, N, S. Okay. These are letters of the given word Sachin. And here we have to find the serial number of Sachin. So now the number of words starting with A is basically factorial 5. Okay. So you can find number of words starting with A is factorial 5. You can find the number of words starting with C is factorial 5 also. And you can find the number of words starting with H is factorial 5 also. Okay. And the number of words starting with I is factorial 5. And the number of words starting with N is factorial 5. Clear? Then next word will be Sachin. So we have to find the serial number of the word Sachin. So the required serial number is basically here number of words starting with A is factorial 5, number of words starting with C is factorial 5, number of words starting with H is factorial 5, number of words starting with I is factorial 5. Okay, and number of words starting with N is factorial 5. So we have here 5 times factorial 5. Okay, and plus 1. So that is 601. So this is the required serial number of the word Sachin. Clear? Are you getting? Do you understand? Do you have any doubt? If you have any doubt, then you can ask freely. Do you have any doubt? I hope you have no doubt. So that's all for today's lecture. Thank you for your attention. I hope this lesson was helpful to all of you. Hello students, in today's lecture we are going to learn about system of particles and rotational motion. This is theory part 2. Alright, this is our disclaimer. In today's lecture we will cover some important topics. First, concept of rotational motion, then equation of rotational motion. After that we will discuss moment of force, or we can say torque. Then we will discuss angular momentum. After that, conservation of angular momentum. Then equilibrium of rigid bodies. Then rigid body rotation. Then pure rolling motion. Then rolling without slipping. Then impure rolling motion. And then rolling on an inclined plane. Then important terms related to inclined plane. After that, and last, we will discuss rotation about axis through center of mass. Alright, so these are the topics of the today's lecture which we will discuss one by one. So are you ready? Yes or no? So first concept is concept of rotational motion. Suppose when a rigid body rotates around a fixed axis. You know rigid body, the shape and size never be changed. Okay, so when a rigid body rotates about a fixed axis, every particle within that body traces a circular path. Alright, the important point here is this: each such circular path lies in a plane perpendicular to the axis of rotation, or we can say the center of this circular path is located on the axis itself. This means that if you pick any particle in the rigid body, alright, so it will revolve around the fixed axis in a circle, and the radius of this circle depends on the distance of that particle from the axis. Now we will discuss some important formulas. So first is omega, or means angular velocity. So if we talk about the first angular displacement, so we can say angular displacement denoted by d theta, okay, and angular velocity denoted by omega. So there is a relation between angular displacement and angular velocity. Okay, let's see. So angular displacement is the measure of how much an object has rotated about the axis in the terms of angle. Okay, so it is actually measured in radians. If theta is the angular position at a given time, then the infinitesimal change in this angle over a small time interval dt is given as d theta. So that relation is omega equal to d theta upon dt. And we know omega is angular velocity. So if we talk about the angular velocity, so we can say d theta upon dt. Okay, and if we talk about the angular acceleration, so it will be alpha equal to d omega upon dt. Now here one important thing, and that is if the angular velocity is not constant, okay, that is the body speeding up or slowing down its rotation, then the rate of change of angular velocity with respect to time, okay, with respect to time is called angular acceleration. So look at here, alpha equal to this one, alpha equal to this one, okay, d omega upon dt, rate of change of angular velocity with respect to time. Alright, so we can say alpha equal to d omega upon dt, and this formula is very important. their students for the exam okay. Omega is equal to d theta upon dt, alpha equal to d omega upon dt. Now if we talk about the SI unit of angular acceleration, okay, so the SI unit of angular acceleration is radians per second squared. All right. Angular acceleration alpha and linear tangential acceleration at are correlated as at equal to alpha into r. Okay, this is the formula. This formula shows how the linear acceleration experienced by a point on the rotating body depends on both the angular acceleration and how far that point is from the axis. So here angular acceleration is alpha and the distance is r. Okay. Now we will discuss some important equations, or we can say equations of rotational motion. If angular acceleration alpha is uniform, okay, or we can say uniform angular acceleration. So in that case, angular acceleration alpha remains constant, okay, throughout the motion, and the rotational motion can be described by a set of equations similar to kinematic equations for linear motion. Let's see each equation one by one. So first equation, omega equal to omega naught plus alpha t. This is angular velocity as a function of time. All right. This equation we can say states that the angular velocity at any time t is the equal to initial angular velocity omega naught plus product of angular acceleration alpha and the time elapsed t. Okay, so it directly follows from the definition of angular acceleration as the rate of change of angular velocity. The second equation, angular displacement as a function of time. Okay everyone, these equations are clear? First one is clear? VK, Varsha, Karthik, Dhruv. Any doubt? So the second equation, angular displacement as a function of time. So theta equal to omega naught into t plus alpha 1 by 2 alpha t square. This equation, or we can say this second equation, gives the total angular displacement theta after time t. Okay, so or we can say it consists of two parts: the angular displacement due to the initial velocity omega naught t, and the additional angular displacement caused by angular acceleration 1 by 2 alpha t square. Okay, so this the second equation is also important. Now we will talk about the third equation, the relation between angular velocity and angular displacement. Omega square minus omega naught square is equal to 2 alpha theta. This equation relates the square of the angular velocity omega at time t to the initial angular velocity omega naught and the angular displacement, okay, theta, without explicit involving time. So it is a useful when time is not known or needed. And fourth equation is angular displacement in the nth interval, theta nth, which is equal to omega naught plus alpha by 2 multiply with 2n minus 1. This equation gives the angular displacement of the nth time interval assuming equal time intervals. Okay, it shows how the displacement changes incrementally as the body rotates under uniform angular acceleration. So in simply we can say these four equations are very important for solving numericals. Okay, in the examination question directly asked from these equations. So you need to remember all these 4 equations: first, second, third, and fourth. All right, everyone? If yes, thumbs up in the chat box. Yes, I expect a reply from everyone. Okay. All right. Now let's see moment of force or torque. Basically, torque is the turning effect, okay, produced by a parallel applied to a point on a rigid body about a specific axis of rotation. In simple terms, it measures how much a force causes an object to rotate around an axis. Mathematically, tau equal to r cross f. This is the mathematical relation. When we solving cross product, it will be mod of r cross f and cap. Okay, it will be rf sine theta and cap. Here r is the vector from the axis to the point where the force is applied. F is the force applied. Okay, and if we talk about the magnitude, it is rf sine theta. Okay, theta is the angle between r and f. And if we talk about the direction, so we can say n cap is a unit vector along the axis of rotation, or we can say perpendicular to plane formed by r and f. And if we talk about the nature of torque, so we can say torque is an axial vector or pseudo vector, meaning it points along the axis of rotation. Its SI unit is Newton meter. So the torque about an axis or rotation does not depend on the choice of origin O, as long as that origin lies on the axis AB. This means the calculated torque, we can say, remains the same, okay, if the reference point is moved along the axis of rotation. So only the normal component of the force relative to position vector r contributes to the torque. Okay, radial component of the force does not create torque because it does not cause rotation. It only pulls or pushes along the radius. Torque is responsible for producing angular acceleration. Okay, angular acceleration alpha. So there is a relation between torque and alpha, tau equal to I alpha. As shown in the figure, here a force capital F applied at a distance r, okay, from a fixed axis O. So making an angle theta with the position vector r. So the torque produced is given by tau equal to rf sine theta, which means the force's perpendicular component to r causes rotation. So torque is maximum when theta equal to 90 degree and 0 when theta equal to 0 degree or 180 degree. Okay, and you know the relationship tau equal to I alpha. Next is moment of a couple. Basically, a couple consists of two equal and opposite forces, okay, separated by a distance. So the moment of a couple or torque is the product of position vector r between forces and the one of the forces F. So tau equal to r cross F. This moment tries to rotate the body but does not produce any net force. Okay. So these all points are work as a booster for your exam. So you need to remember all the important points and the formulas. Okay, everyone. So if we talk about work done, so we can say when a body is subjected to an external torque tau. It causes the body to rotate by a small angle d theta. Okay, so the work done by the torque during the small angular displacement d theta is the dot product of the torque vector and the angular displacement vector. So dw equal to tau dot d theta. The work done depends on both the magnitude of the torque and the component of the angular displacement in the direction of the torque. If we talk about power in rotational motion, so we can say power is the rate at which work is done by this torque. Alright, a mathematical formula P equal to tau dot omega. Power is scalar product of torque and angular velocity. Power depends on how large the torque is and how fast the body rotates. Okay, in the torque's direction, if the torque and angular velocity are aligned, power is maximized, and if perpendicular, no power is delivered. Okay, angular momentum. So here question arises, what is angular momentum? Think about it. The moment of linear momentum of a body about an axis of rotation is called its angular momentum. Okay, suppose a particle has linear momentum p equal to mass into velocity, where m is its mass and v its velocity. Okay, and r is the position vector of the particles measured from the axis or point of rotation. Then the formula to calculate the angular momentum L equal to r cross p. Okay, and if we solving the cross product, you will be get r p sine theta n cap. Here theta is the angle between r and p, and n cap is the unit vector perpendicular to plane containing r and p and indicating the direction of angular momentum following the right hand rule. Okay, so we can write mvr sine theta n cap, and we know n cap is unit vector in the direction of rotation. Alright, and SI unit is joule second. Angular momentum is an axial vector. What is the axial vector? So we can say it points along the axis of rotation. Okay, that's why we called axial vector. For a rotating rigid body, the total angular momentum about the axis of rotation is related to its angular velocity omega and moment of inertia I. So the moment of inertia I depends on mass distribution of the body relative to axis of rotation. Mathematically we can write L equal to I omega. So according to second law of rotational motion, the rate of change of angular momentum of a body is equal to external torque applied on it, and it take place in the direction of torque. Okay, so we know tau equal to what? dl upon dt. The change in angular momentum occurs in the direction of applied torque. This principle is analogous to Newton's second law in linear motion, where force changes linear momentum. Okay, so the applied torque causes the body to either speed up or slow down or change the direction of rotation depending on its magnitude and direction. Alright everyone, VK versa, clear? Yes or no? Tell me. Any doubt here? Yes sir, please yes, please ask. Any doubt here? So torque can be written as tau equal to dl upon dt equal to differentiation of L, that is I omega with respect to time. So it will be I d omega upon dt equal to I alpha. Okay, differentiating L with respect to time. Therefore, the angular acceleration is alpha equal to d omega upon dt. When a torque acts over a time interval delta t, its cumulative effect is the angular impulse. And angular impulse is equal to total change in angular momentum of the system in a given time. So the angular impulse J is the integral of the torque over the time interval from 0 to delta t. So J equal to what? Integration 0 to delta t tau dt, that is equal to delta L equal to LF minus LI. Here Li is the initial angular momentum and LF is the final angular momentum. This means angular impulse equals the change in angular momentum caused by the torque applied over the time interval. For n particles, okay, so the total angular momentum about the origin is vector sum of individual momenta. So the formula is L equal to summation I equal to 1 to n Ri cross Pi. Okay, Ri is the position vector and Pi is the linear momentum. Law of conservation of angular momentum. So firstly we will discuss definition. So according to law of conservation of angular momentum, if no external torque acts on the system, then the total angular momentum of all particles in that system remains constant. Okay, this means the system's overall spinning motion cannot change unless an outside twisting force is applied. We know that the rate of change of angular momentum L with respect to time t is equal to external torque tau external. If there is a no external torque, that is tau external equal to 0, then the angular momentum does not change over time. So dl upon dt equal to 0, L equal to constant. Therefore, in the absence of any external torque, the total angular momentum of the system must remain conserved. Okay, this principle applies to all rotating systems from spinning planets to ice skaters. If we compare linear and rotational motion, then we can say linear momentum P equal to mass into velocity, angular momentum L equal to I omega, force F equal to ma, whereas torque that is denoted by T and also tau. So we can say tau equal to I alpha or T equal to I alpha. Both are correct. In different books, torque represented by capital T in or tau. Okay. And third, translational kinetic energy kT equal to 1 by 2 mv square and rotational kinetic energy kr equal to 1 by 2 I omega square. So this is the comparison between a linear and rotational motion. Okay. For mechanical equilibrium of a rigid body, two conditions needed to be satisfied. First, translational equilibrium, and second, rotational equilibrium. If we talk about the translational equilibrium, so we can say the rigid body either stays at rest or moves with a constant velocity in a straight line. This happens when the next external force acting on the body is 0. Okay, in other words, the vector sum of all the external forces on the body must be cancelled out. So F equal to 0 or F equal to sum of all forces equal to 0. When this condition is met, there is a no change in linear motion of the body. Alright, this is all about the translational equilibrium. Next we will discuss rotational equilibrium. So rotational equilibrium means that the body, a rigid body, either does not rotate or rotates with a constant angular velocity. This happens when the net external torque acting on the body is 0. So the vector sum of all torques must be 0. So tau external equal to 0. So dl upon dt equal to 0. Okay. So summation I tau equal to 0. This condition ensures there is a no change in rotational motion of the body. So this is the translational equilibrium and rotational equilibrium. Rigid body rotation. First, spinning. So when a rigid body rotates such that its axis of rotation remains fixed in space and does not move, this type of motion is called spinning motion. In spinning, the body rotates around a fixed axis. So the rotational kinetic energy of a spinning body or spinning rigid body measures the energy due to its rotation. It depends on the moment of inertia I of the body about the axis of rotation and angular velocity omega. Okay, and the formula for rotational kinetic energy is kr equal to 1 by 2 I omega square, where kr is the rotational kinetic energy, I is the moment of inertia, and omega is the angular velocity. Rotational kinetic energy is a scalar quantity, meaning it has magnitude but no direction, and its SI unit is joule. The same unit used for all forms of energy. Okay, so this is a direct relationship between rotational kinetic energy and um we can say angular momentum L, so of the spinning body. So this relationship is expressed as kr equal to L square divided by 2I, or eventually L equal to under root 2I kr. Here capital L is the angular momentum. Okay, so this formula shows how the energy of rotation and the angular momentum depend on each other through the moment of inertia. Okay, clear? Any doubt? VK? Varsha? If yes, please ask. Alright. Now let's see pure rolling motion. So consider a rigid body with a symmetric surface about its center of mass. So suppose this body is spun at a certain angular velocity omega and placed on a surface so that its plane of rotation is perpendicular to that surface. If the body is also given translational motion with velocity v simultaneously, then the combined motion of spinning and translation is called rolling motion, as shown in the figure. Okay, the velocity is v and angular velocity omega. So in pure rolling motion, the body both rotates about its center of mass and moves forward without slipping. So the total kinetic energy in this motion is the sum of two parts, the rotational kinetic energy kr and translational kinetic energy kt. So we can write kn equal to kr plus kt. The translational kinetic energy is kt equal to 1 by 2 mv square, where m is the mass of the body and v is the velocity of its center of mass. So the rotational kinetic energy is kr equal to 1 by 2 I omega square. So using the relation, okay, using the relation between angular velocity and linear velocity in rolling motion, omega equal to v by r is the radius. So defining the radius of gyration k such that I equal to mk square. So the kinetic energy can be written as this one, mv square plus 1 by 2 mv square into k square by r square.
Okay, kn equal to 1 by 2 mv square into 1 plus k square by r square. Now we will discuss rolling without sleeping. Okay, so when a rigid body rolls over a surface in a such a way that there is no relative motion between body and surface at the point where they touch, this type of motion called rolling without sleeping. Or we can say in rolling without sleeping, the point of contact on the rolling body is momentarily at rest with respect to surface. This means the velocity of the point of contact relative to surface is zero. Look at here, the figure shows the rigid circular body, okay, such as a wheel or ball. So rolling on flat surface, okay, the body is moving forward with a linear velocity v at its center of mass, indicating by a right arrow, okay, pointing to the right. Simultaneously, it is rotating with angular velocity omega, okay. So at the point of contact P between the body and surface, the rotation causes a velocity omega r directed opposite to the translational velocity v. So in rolling without slipping, these two velocities are exactly equal in magnitude but opposite in direction. So they cancel out at the contact point. This means the velocity of point P relative to the surface is 0, and thus there is a no relative motion, or we can say no relative motion or slipping between the body and the surface at that point. This condition ensures smooth rolling motion where the body rolls over the surface without sliding. Okay, impure rolling motion. In impure rolling motion, the point of contact of the rolling body with the platform is not at rest relative to platform on which it rolls. This means the contact point slides or slips rather than purely rolling, leading to frictional sliding at the interface. The figure here shows a rolling body with center of mass, center velocity v, okay, and angular velocity omega on a platform moving at velocity v naught. So the contact point A moves at the velocity r omega relative to the center. Since v minus um r omega not equal to v naught, the contact point sleeps on the platform. Okay, that illustrating impure rolling motion. So in the figure, the platform is moving with velocity v naught. So, but the contact point A moves at velocity r omega. Okay, which is not equal to v naught, leading to sliding. So this shows impure rolling motion where v minus v naught not equal to v naught, and point of contact slides on the platform. So when the platform is stationary, that is v not equal to 0, impure rolling motion means v not equal to r omega, implying the linear velocity of the center is not equal to tangential velocity at the rim. So causing slipping at the contact. Thus the figure visually, here we can say visually confirms the condition of impure rolling motion by illustrating the mismatch between the velocity of contact, or we can say point on the rolling body, and the velocity of the platform. Okay, everyone, clear? Any doubt? Yes, Varsha, VK, any doubt? Now, rolling motion on an inclined plane. So, suppose when a body of mass small m and radius r rolls down on an inclined plane. Look at here, having height h, this one, and angle of inclination theta. It loses potential energy due to the change in vertical height. Okay. However, as it rolls, the body gains kinetic energy in two forms. First, kinetic energy of translation due to its linear velocity, and the kinetic energy of rotation due to its angular velocity. This means a total kinetic energy is the sum of translational and rotational energies. So this figure shows uh, body of radius r placed at the top of an inclined plane with height h and angle of inclination theta. Okay, so body is about to roll down the slope starting from rest. So the inclined plane we can say depicted as a right angle triangle where the vertical height is small h and the length along the slope is small s. As the body rolls down, okay, so it converts the potential energy mgh into kinetic energy, which includes both translational kinetic energy because the body moves linearly along the slope, and the rotational kinetic energy because the body spins around its axis. So the radius r and the theta angle are essential in describing the geometry of the rolling motion and relate to the distance traveled s down the incline. So by the conservation of mechanical energy, mgh equal to 1 by 2 mv square into 1 plus k square by r square. Okay. And from the above equation, we can solve for the velocity v at the lowest point of the incline as v equal to under root 2gh divided by 1 plus k square by r square. This formula shows that the velocity depends on both the height h and the moment of inertia k. Okay. And to find the acceleration a of the body as it rolls down, we use the second equation of motion, v square equal to u square plus 2as, where u is the initial velocity, s is the distance traveled along the incline, and a is the acceleration. Knowing v and s, we can calculate a. Okay, these formulas are very important for the exam. Rolling on inclined plane. So when an object rolls down an inclined plane without slipping, its initial velocity is 0. Okay, so the distance traveled along the incline is s is equal to h by sine theta, where h is the vertical height and theta is the angle of inclination. And the final velocity v of the rolling object at the bottom is given by v equal to under root 2gh divided by 1 plus k square by r square, where g is the acceleration due to gravity, k is the radius of gyration of the object, and r is its radius. Okay, so this formula incorporates both translational and rotational kinetic energy. So the acceleration a of the object rolling down the incline is a equal to g sine theta divided by 1 plus k square by r square, showing that the acceleration is reduced compared to a sliding object due to rotational inertia. So using the equation of motion v equal to u plus at with u equal to 0, and substituting the value of b and a, the time t taken to descent is t equal to 1 upon sine theta under root 2h divided by g 1 plus k square by r square. So from these it follows that v is directly proportional to 1 divided by under root 1 plus k square by r square, a is directly proportional to 1 divided by 1 plus k square by r square, and t is directly proportional to under root 1 plus k square by r square. This means velocity decreases, acceleration decreases, and the time of descent increases as rotational inertia increases. So this is the correct relation. VA and T. Okay everyone, all these formulas are very important, so you need to remember this. Important terms related to inclined plane. So here the factor k square by r square represents the moment of inertia of a rolling body relative to its radius. Okay, this factor depends only on the shape of the body and remains constant for a given shape. It is important to note that it does not depend on the mass or radius of the body itself. The velocity, acceleration and time or time of descent of a rolling object on an inclined plane all depends on the value of k square by r square. Specifically, a smaller moment of inertia corresponds to a smaller value of k square by r square. Okay, when k square by r square is smaller, uh, we can say the rolling body will have a greater velocity and acceleration while descending the incline. So at the same time, the time taken to reach the bottom of the incline will be shorter. Alright. Now rotation about a fixed rotation about axis through center of mass, or we can say centroidal rotation. So consider an object having mass m that is attached to a light inextensible string. This string is bound around a pulley or wheel which can rotate freely about its central axis. So the pulley has a moment of inertia I about this axis and radius capital R as shown in the figure. So here a pulley mounted on a frictionless bearing allowing it to rotate without a resistance, and a string is wrapped around the pulley's rim and the object mass m is suspended from the string. Okay, here when the object is released its acceleration downward. Okay, this and with downward with acceleration a while the pulley rotates due to tension T in the string, this one. Okay, so the system assumes that the string does not slip on the pulley's rim, meaning the linear acceleration of the falling mass and the angular acceleration of the pulley are related by a equal to r alpha, where alpha is the angular acceleration of the pulley. So the tension T in the string given by T equal to I divided by I plus mr square into mg. This formula shows that the tension depends on the ratio of the pulley's moment of inertia I to the combined rotational inertia terms I plus mr square multiplied by the weight mg of the falling mass. And acceleration a of the falling mass is a equal to mr square divided by I plus mr square into g. So this expression shows the acceleration is less than g, acceleration due to gravity, because some energy goes into rotating the pulley. Okay, so this is the summary of our lectures. First we already discussed concept of rotational motion, then we discussed equation of rotational motion, then moment of force, then angular momentum, then equilibrium of rigid bodies, then rigid body rotation, then pure rolling motion, then rolling without slipping, then impure rolling motion. Okay, someone asked about the impure rolling motion. So rolling that includes slipping, okay, that type of motion is impure rolling motion. Varsha khare. Rolling on an inclined plane. Okay, then important terms related to inclined plane. Then we discussed rotation about axis through center of mass. All right, everyone. Yes or no? If yes, then write in the chat box. Clear? Varsha, VK, Karthik. All right. Thank you. Now we will solve some practice questions based on these concepts. All right. So, are you ready for the questions, everyone? If yes, tell me. Hello, everyone. Now we will solve some practice questions based on system of particles and rotational motion. Okay, and this is practice question part 2. So this is our disclaimer. So here we will solve some practice questions based on system of particles and rotational motion. So question first, when a body is projected at an angle with horizontal in the uniform gravitational field of the earth, the angular momentum of the body about the point of projection as it proceeds along the path is what? So when a body is projected like this, look at here, and this is 0 0 origin, and this is vertical, this is horizontal axis, and this is vertical axis. So when a body is projected, so body move in 2 dimension along x axis and along y axis. So and the body also having in under the uniform gravitational field of the earth. Okay, so in that case the weight of the body always acting vertically downwards, that is mg. So here when the body follow a trajectory like this, so what will be the effect on the momentum? Okay, given options, option A remains constant, option B increases continuously, option C decreases continuously, and option D initially decrease and after reaching the highest point increase. So students, tell me which option is correct. Yes, you have some time. Please solve this question, everyone. Which one is correct? Suparna, Varsha, VK, Karthik. Which option is correct? Good, good, VK, good. Let's see the solution. So correct option is B. All right. So we know the formula of the torque, tau equal to R cross F. All right. And here a body is projected at an angle with horizontal in the uniform gravitational field, and question asks about the what will be the effect on angular momentum. Okay, angular momentum. So when body follow this trajectory with velocity v, so we know that tau equal to R cross F. And what is F? F equal to mg, that is yes or no. So as R perpendicular, okay, is continuously increasing when the body follow this trajectory. So the R perpendicular is continuously increasing, or torque is continuously increasing. When R increasing, torque increasing. Okay, so on the particle, hence the angular momentum of continuously increasing. Okay, they are directly related. A force of minus F k cap acts on origin, the origin of the coordinate system. Okay, the torque about the point 1 and minus 1 is what? So here you have to find out the torque. Given options: option F I cap minus j cap, option B minus F I cap plus j cap, option C F into I cap plus j cap, and option D minus F I cap minus j cap. So which option is correct? This is very simple question. You need to just put the all the given terms in the formula of torque, that is R tau equal to R cross F, and you know the value of R and you know the value of F. So just take the cross product and find out the answer. Yes, please try to solve this question, everyone. Yes, which one is correct? If the question is clear, thumbs up in the chat box. Everyone, Varsha, VK, if the question is clear. Anyone? Let's see the solution. So correct option is B. So here, according to question, a force F uh, minus F k cap. Okay, minus k cap means this is the z direction, and the opposite of z is this one. So force acting in this direction. So the torque about the point 1 and minus 1. So firstly, we will find out the R, and then we will put the value of F and take the cross product. So here R will be what? The coordinates is 1 and minus 1. So it will be what? R is equal to I cap minus j cap with minus sign, cross F is what? Minus F k cap. Alright. So when you take the cross product, you will be get tau equal to f into minus j cap plus minus I cap. When we solving this, you will be get the this. So V1 is correct. Just you need to take the cross product. That's it. I think C option is correct. Okay, in previous question. So third one, the angular momentum of the particle rotating with a central force is constant due to what? Given options: option A, constant force; option B, constant linear momentum; option C, zero torque; and option D, constant torque. So which option is correct? A, B, C, D. Think about it. Yes. Yes, there's an in that question, there's a no need to negative sign. All right, you are correct. VK, you are correct. Okay, so the answer will be with negative sign. So which one is correct? Yeah, correct. Good. Let's see the solution. So correct option is C. So torque due to central force is zero. You know that. So when we differentiate angular momentum with respect to time, so tau equal to 0. Therefore, L equal to constant. Alright. Yes, your answer is correct, Varsa. Your answer is correct, VK. Good, very good. Next one. A particle of mass m equal to 3 kg moves along a straight line 4y minus 3x equal to 0, where x and y are in meter with constant velocity v equal to 5 meter per second. The magnitude of angular momentum about the origin is what? Given options: option A, 12 kilogram meter square per second; option B, 8 kilogram meter square per second; option C, 6 kilogram meter square per second; and option D, 4.5 kilogram meter square per second. So which option is correct? Think about it and please try to solve this question. Which one is correct? So correct option is C. Okay, let's see the solution. So according to question, mass is 3 kilogram, moves along the straight line 4y minus 3x equal to 0. Okay, and velocity is 5 meter per second. So first we will write equation of straight line, that is 4y minus 3x equal to 0. So using this equation we will draw a straight line AB. Okay, so when we solving this, you will be get 3 by 4 x plus 0.5. Okay, So when we calculate the slope, so tan theta equal to what? 3 by 4. So theta equal to what? 37 degree. This one. So here to calculate the R perpendicular, that is 2 by 3 sine 53 degree, we will solve this expression. Okay, the R perpendicular is this one from the origin to line AB. So angular momentum here L equal to MVR perpendicular. This one. Okay. So L in just put the value of M, V and R. So it will be 3 into 5 into 0.4. So when we solving this, you will be get 6 kilogram meter square per second. Okay, good. Your option is correct, Varsha VK. Good, very good. Next one, a particle of mass m moves along line PC, P2, this one line PC. Okay, so with velocity v and as shown in the figure, what is the angular momentum of the particle about O? Given option A mv into capital L, option B mvl, option C mvr and option D 0. So which option is correct? Think about it. So correct option is B. Let's see. So we know the angular momentum of the particle, that is L equal to m into r cross v. So if we talk about the magnitude, so it will be mvr sine theta. Okay, so just put the value of mv and r sine theta. So you know r sine theta is what? That this one, r sine theta is this one. It is L. So magnitude of L equal to mvl. So in terms of notations, it will be mvl. If you know the value of mvl, then you will be get the angular momentum of the particle. All right. This question: a particle of mass 5 gram is moving with uniform speed of 3 into root 2 centimeter per second in the xy plane along the line y equal to 2 into root 5 centimeter. The magnitude of its angular momentum about the origin in gram centimeter square per second is what? So here you have to find out the magnitude of its angular momentum. Please solve this question. Given options: option A 0, option B 30, option C 30 into root 2, option D 30 into root 10. Which option is correct? Yes, everyone, please try to solve this question. Which one is correct? So correct option is D. So we know the formula of L, that is mvr1. So just put the value of mv and r1 and you will be get the value of L, 30 into root 10 gram centimeter square per second. Okay. This question: a cylinder having radius 0.4 meter initially rotating at t equal to 0 with omega naught equal to 54 radian per second is placed on a rough inclined plane with theta equal to 37 degree, having frictional coefficient mu equal to 0.5 as shown in the figure. The time taken by the cylinder to start pure rolling is what? Given option: option A 5.4 second, option B 2.4 second, option C 1.4 second and option D 1.2 second. So which option is correct? Please solve this question, everyone. This is very important question. Yes, which one is correct? Varsha, VK, you have some time, please solve. And if you have any doubt in any question, please write in the chat box. Okay, good. Anyone? Yes, which one is correct? The correct option is D. Good. So firstly, we will draw the free body diagram. So we know uh, the weight of the cylinder is vertically downward, that is mg, and the frictional force we can see uh, mu mg here, mu mg cos theta, and if the take the component, so it will be mg sin 37 degree and mg cos 37 degree. So in terms the here frictional force is F by m. Due to this acceleration become mu g cos theta. So this mg is cancelled out by m. This m is cancelled out by the denominator m plus g sin theta. So when we putting the values, you will be get a equal to 10 meter per second square. Okay. So and angular acceleration alpha equal to mu mg cos theta r divided by 1 by 2 mr square. So solving this, you will be get 2 m mu g cos theta by r. So just put the value which is given in this question and you will be get 20 radian per second. This is just numerical part. Okay everyone. So pure rolling will start when v equal to r omega, where v equal to a cross t and omega equal to omega naught minus alpha t. So solving this with this expression at equal to r into omega naught minus alpha t, you will be get 10 t equal to 0.4 into 54 minus 20 t. So it will be 1.2 second. Okay. So the time taken by the cylinder to start pure rolling is 1.2 second. Alright everyone. So that's all for the today's lecture. Thank you for your attention. Thank you. Thank you everyone.